He drifts toward a star that does not glow in welcome. Its light arrives like a warning, white as cut bone and sharpened by a field that grips the void. To the lens, it looks small, hardly bigger than a city, yet it pulls at everything near it with a hunger that feels older than gravity itself. In the cold around it, dust does not drift. It bristles. Photons do not travel. They are herded. Space responds as if a hand were drawing invisible threads tight. He slows the camera, and the star answers with a shiver of high-energy light. The airless dark blooms with hard X-rays. A surface no wider than a continent flares bright enough to shame entire galaxies for a heartbeat. Nothing about this should be gentle. Nothing about this should be quiet. The star is a sealed furnace, a pressure poem, a relic of collapse that learned a new way to scream. It spins. The spin is not a dance but a sentence. It turns every few seconds, sometimes faster, a rotation so exacting that time itself could be measured against it. Each sweep drags colossal fields through the emptiness, combing the vacuum until the vacuum stops behaving like nothing. In that combed space, particles appear and vanish in a fever of pairs. The fields are not content with silence. They make matter from restlessness. He presses nearer, and the skin of the star comes into view. It is not skin in any earthly sense. It is a crust of hyperdense crystal, iron lattices, stacked under pressures that would grind mountains to smoke. The crust is scored with lines that are not cracks, as much as grim signatures of strain. Each line hints at the next fracture, the next convulsion, the next moment when the star will remind the galaxy of its presence. Somewhere beneath that crust, superfluids whirl and superconducting seas hum with buried motion. The fields snake outward from those hidden currents, threading the magnetosphere with loops so tight that geometry seems short of words. Silence is not absence here. Silence is suspended threat. The star waits, and in its waiting the universe reveals a different character. He senses it in the way distant gas responds, in the way charged particles spiral along unseen rails and arrive in sprays that etch their passage on detectors half a galaxy away. He senses it in the memory of fragile worlds that once wandered too close and were reduced to chemistry, and then to ions, and then to rumour. This is not the kind of star that makes planets. It is the kind that unmakes certainty. It was born at the very end of fury, when a massive star collapsed, and the core paused at the edge of further collapse. The pause was a compromise with physics. Matter agreed to stand up as a neutron sea so dense that a teaspoon would outweigh mountains, and in return the universe permitted the remnant to exist. In that pact, magnetism found an opportunity. What emerged was not simply a neutron star, but a field wound to titanic intensities, a geometry of strength that lifts itself above ordinary comparison. Some fields here could strip the electrons from atoms across thousands of kilometers. Some fields here could force empty space to behave like a crystal that bends light. He keeps the camera fixed, letting the star turn. As it turns, light pulses arrive with metronomic regularity. The pulses precede and follow cracks of violence, each a signature from hotspots carried in and out of view by the spin. There is a temptation to call it predictable. That would be a mistake. Predictability dissolves in an instant when the crust decides to shift. Then the pulses stutter. Then the star reveals that even its clock is only a map, not the territory. In those missteps, observers glimpse the scale of forces inside, where superfluid vortices pin and unpin, where pinches of nuclear matter realign, where order chooses a new arrangement without warning. A breeze across an autumn field can carry the sound of insects. No breeze runs here, yet the fields carry their own kind of whisper. It is heard in polarizations, in subtle rotations of light that escape the glare with its history intact. That history records a passage through regions where virtual things become briefly real, where the quantum nature of the void is not an abstraction, but an environment. The star writes its biography into that light. The biography names, pressures, inscriptions, fractures, temperatures beyond ordinary scales, and a temperament that is both relentless and strange. He imagines approaching closer, and the imagination recoils. Near the star, the definition of safe distance is rewritten. Organic chemistry would fail first. Then, electronics would give way, as currents appear without wires, as circuits conduct what they never agreed to carry. Even metal would lose humility and try to align with the fields. A ship would not approach so much as surrender. Navigation would lose meaning because space here is threaded by directionality more rigid than coordinates. Every path is a choice made by magnetism, and magnetism is not interested in accommodation. Still, the pull to understand is stronger than the instinct to back away. He holds the shot. The star offers a sudden brightening that seems almost like acknowledgement. It is a flare, quick and brutal, a venting of energy that rose from the rearrangement of field lines in a magnetosphere twisted past patience. Light arrives not only as brightness, but as texture. There is a granularity to the flash, an imprint of the field topology that released it. In the afterglow, the star appears unchanged, but that is surface illusion. Inside, new stresses are already migrating, seeking weak lines where the next release will launch. He thinks of names because names are what minds use to grasp what exceeds them. The most accurate names are simple: magnetar, a term that holds the essence of the beast without ornament. It is a star of magnetism, a machine of tensile violence that uses rotation and field to convert stored internal order into light and particles that flee. He does not need to invoke metaphor to find the poetry. The poetry is the event itself, a city of matter, under the weight of its own gravity, armored in crystal, wired with currents that no laboratory can mimic, turning again and again beneath stresses that are never content to rest. Around it, the galaxy is not a passive canvas. The star announces itself to clouds that might remember it for 1,000,000 years. It leaves fingerprints in the timing of other bodies that feel its distant tug. It may call to itself a companion, or it may stand alone in the dark. If a companion approaches, new dynamics arise. Accretion can feed the field, and feeding can become a ritual of spikes and pauses, of heat splayed across magnetic poles where arcs rise like mountains no one will climb. The sky would glow in lines and knots. The glow would hint at architecture, at shapes forced on plasma by a tyrannical order that does not tolerate improvisation. The camera pulls slightly back. The star remains the center of the frame, yet the wider shot reveals the environment that sustains its menace. Remnants of the progenitor drift as a ragged nebula. The nebula is not quiet either. It carries shock fronts and ripples where earlier outbursts ran outward and compressed what they struck. In those ripples, cosmic rays begin their long travel. In that travel, the larger galaxy gains a few more threads of influence from a single point that looks so small against the sea of stars. He considers the numbers because numbers translate awe into a language instruments can certify. The field might exceed a quadrillion Gauss. The density might crowd a solar mass into a sphere 20 kilometers across. The rotation might clock several revolutions per second. The flare might outshine the entire Milky Way for a fraction of a second. These are not exaggerations. They are the natural outputs of matter forced into relationships that follow the letter of physics, yet stretch the spirit of comprehension. He does not flinch from the danger, because fear is not the point. Attention is the point. A star like this refines what attention is for. It becomes a school in which nature teaches that risk and revelation often share a border. Look long enough and a lesson emerges in shapes that belong to plasma and curvature and quantum vacancy. The lesson is simple to state and difficult to assimilate. The universe is not designed for comfort. It is designed for narrative, and the narrative here is concentration. Energy that would be diffuse elsewhere is gathered into a form that can change nothing for long ages and then change everything in a flash. He holds the final seconds of the shot in stillness. The star spins, the light sharpens, the fields tighten. There is no soundtrack except what the detectors imagine. There is no need for metaphor beyond the fact. A small star holds a large threat, and in holding it, reveals a kind of beauty that does not negotiate. The camera lingers until the eye understands that this beauty is exacting, and that to witness it is to accept the gravity of its terms. He sits in a control room where the night does not end. The room is a constellation of screens, each fed by quiet machines in orbit and on the ground. On one screen, a curve climbs, holds a heartbeat, then falls. It is not the first time that curve has risen from that part of the sky. It is the repetition that chills. Gamma light has the personality of lightning. It favors surprise. Yet this flash wears a habit. It returns to its own coordinates as if a lighthouse were standing in the starfield, turning with a timed impatience. The first warnings did not arrive as grand announcements. They arrived as brief spikes in detectors that were designed for cosmic accidents. Engineers checked cables, analysts checked algorithms. Someone whispered solar flare and looked to the sun's face for corroboration. The sun remained ordinary. The spikes continued. They came soft in energy, but hard in intent, rising in milliseconds, stepping down in jagged tails, and then resting in silence that never promised peace. He runs through the archives. There is a date in spring when instruments across the solar system flinched together. A wave raced through Earth's neighborhood so quickly that timing alone could identify its violence. Satellites shielded by different budgets and nations recorded the same shape. Interplanetary timing told a story of arrival from far outside the planetary wind. Triangulations sketched a region in the sky, not a pinpoint, but a promise that a pinpoint could be coaxed from the data with patience. The patch overlapped a ragged cloud of starlight where remnants lie like scars. A noisy coincidence at first glance. Then the region spoke again. Repeaters changed a field that had been dominated by one-off catastrophes. Classical gamma bursts scattered across the sky like applause, each an unrepeatable moment. The new signals broke decorum. They returned with the confidence of a clock. He watches as mission logs accumulate nights of this behavior. He hears the tone of report writers shift from cautious to intent, then from intent to compelled. The team draws circles on a celestial map. Within those circles, wide-field X-ray eyes begin to search for a colder echo. They find a persistently glowing ember that will not go cold. It is faint by day standards and fierce by the arithmetic of space. It suggests a source that never truly sleeps. Optics do not help much. The visible sky around the coordinates is busy, and dust turns clarity into rumor. Radio dishes strain but hear only hiss. The voice for now is higher and sharper. It speaks in X-rays and gamma spikes that etch their message into detectors with cruel economy. He studies the rhythm and finds that beneath the disorder there is a turn. A period emerges, seconds long. The spike train shows a line of regularity that glides a little with time. It is as if a beacon sweeps a lantern across the night. Each sweep catches the instrument at much the same angle. The shape of the pulses carries the texture of whatever stands on the surface, to glow or darken as it passes through view. Observers become a network. An interplanetary web of spacecraft compares time, stamps and shapes, computing arrival delays that fix the source as cleanly as the geometry allows. A box in the sky shrinks to a square small enough that a deep X-ray image can find a single star-sized point. That point is not a star in any gentle sense. It is intensely hot in the language of soft X-rays. It has no companion that classical optics can certify. Those who search catalogues find that the position lies near a supernova remnant whose threads of gas still drift bright in shock-lit filaments. The implication spreads through the team with a hush that feels like reverence. The flares may not be accidents. They may be the behavior of a child of an explosion, a dense ember that learned to speak in hard light. A few years pass in the span of minutes on his fast-forward playback. New repeaters show themselves in other sky patches. They bear different names from catalogue numbers that carry the smell of coordinates and discovery order, yet their habits rhyme. They sleep for months, then chatter for days. They deliver a sudden giant, a flare so immense that the detectors saturate and the Earth's ionosphere cringes. Radio stations notice their own signals reflect in odd ways as the atmosphere becomes momentarily warped by light that human eyes cannot perceive. He taps a pen against a notebook while reading the reports, small details that betray large forces. One observer joins the record, with a finding that seems quiet and turns loud on reflection. Between the tempests, the source continues to shine in X-rays. It is not a dead coal that glows only when struck. It is a furnace with a pilot flame. The spectrum shows a soft component that suggests a hot surface and a harder tail that implies magnetospheric work. He marks this detail because it argues for a specific kind of engine. Something spins, something harnesses that spin, something stores field like a wound spring. and releases it as if patience were a virtue it does not possess. A different set of watchers treats the rotation itself as a discovery. They time the pulses with the care reserved for metrology labs. They see the rotation wander a little. It speeds up by a sliver in a jump called a glitch. The jump is not huge, but it is abrupt. It behaves like a machine whose internal gears slipped and then caught at a new tooth. Those gears cannot be gears. They must be vortices in a superfluid core, pinned and unpinned, or a crustal lattice that decided to change its grip. The rotational stutter moves the conversation from flare spectacle to continuity. This is an object that can be studied as a lighthouse and a seismograph at once. He turns to names because names help the narrative breathe. The community coins a label that is both restrained and audacious: magnetar. It is an invitation to imagine a neutron star possessed of a magnetic field so overwhelming that it governs physics in its vicinity. The label is not a conclusion. It is a hypothesis with posture. The posture invites tests. Observers respond by measuring polarization in the tails of certain X-ray bursts, looking for the signature of space behaving like a birefringent medium. They examine how low-energy photons are held back by processes called splitting and how this alters the spectrum. Hints accumulate. The hints do not shout. They add up like stones in a pocket until the weight can no longer be ignored. A pivotal day arrives when a flare of historic intensity erupts from a source whose coordinates have become familiar to everyone in the field. Instruments that were never designed to share this moment are temporarily pressed into service. Earth's magnetic envelope rings, particle counters spike. The flare's tail shows a modulation that matches the known rotation of the source. Cause and effect clasp hands in public. A spinning, compact object lies behind the carnage. In the afterglow, telescopes reckon with the idea that the energy released in a fraction of a second could supply a sun for hundreds of thousands of years if it could be bottled. There is no bottle. There is only release. He walks outside at dawn after the long session. He knows that stars are still out there in daylight, radiating steadfastly. The one that has occupied his thoughts is quiet again. Quiet is the wrong word. Quiescent is the word that respects the fire beneath. The data team schedules new observing campaigns. Coordinated observations become the norm. A radio array is instructed to keep watch for a surprise in a lower register. Some days it hears nothing. One day it hears a fast, sharp bark that lasts a few milliseconds. The timing matches an outburst in higher energies. A bridge is hinted between radio storms that flash and vanish across the universe and the more local tantrums of this small, terrible star. The human story gathers around these flashes. A graduate student sees the first spike of a new outburst while eating noodles at midnight. A senior scientist returns from a conference and finds a message that simply reads, "It spoke again." An engineer realizes that shielding will need redesign because the atmosphere can be changed by a star that is thousands of parsecs away. A theorist scribbles a diagram of field lines, twisted into knots, and imagines them snapping like overworked ropes. The community carries the moment in its pulse. He returns to the control room and slows the playback to real time. A small pulse arrives. It is easy to miss. It is not the headline, but it is a line of the story. Without such lines, there would be no book. The team logs it, updates models, adjusts expectations. The source refuses to be reduced to one behavior. It can repeat and surprise, sleep and shout, spin smoothly and stutter. Every trait is a door. Every door opens to a room where new instruments will have to learn how to see. The map on the wall of the control room shows the Milky Way as a river of milky dust. Small marks indicate sources that share this habit of throwing soft gamma knives and then returning to the same address. The marks are not many. Rarity increases the sense of consequence. The sky is vast and rich, yet only a few points choose this form of expression. He stares at the marks a moment longer than necessary, then turns back to the screens. The lesson of repetition has already done its work. It has turned a violent light into a subject that can be pursued with patience. Pursuit will not tame it. Pursuit will illuminate it. In science, that is the same as respect. He enters the chamber where rules become negotiable. Chalk dust hangs like fog over a table, crowded with constants and limits that usually guard the borders of what matter can endure. The usual guardians look uneasy. A single parameter on the board, a magnetic field written in a plain hand, exceeds a quiet threshold that separates ordinary space from a different country. That threshold has a name, the quantum critical field, a level of magnetism at which empty space acquires texture. Above it, the vacuum pretends to be glass. Light does not simply pass, it splits into favored directions. Polarization ceases to be a footnote and becomes a compass. He lingers on implications. In fields that strong, an atom no longer resembles a familiar cloud. Electrons are pressed into Landau orbits, their motion stacked into rungs of a strange ladder. The atom elongates, drawn into a needle along the direction of the field. Chemistry becomes a new language, where bonds form as threads aligned with a cosmic arrow. Iron on a surface so ruled would not behave as iron does in any furnace. It would join a lattice whose strength rivals imagination, a crust so rigid that a mountain would be a whisper inside it. When such a crust snaps, it is not a creak. It is a continent breaking in a soundless shout that only detectors can hear. He weighs the gravity. The surface gravity could rise to 100 billion times that of Earth. A particle tossed upward would not climb. Light itself leaves with effort, red-shifted by curvature into a lower register than it possessed at birth. Even the path of a photon bends enough that more than half the surface is always on display to a distant eye. This gentle bending, married to a violent field, produces a theatre in which hotspots swing in and out of view yet never quite hide. Timing curves are written by a partnership between general relativity and magnetism, a partnership that seldom collaborates so publicly. He notes the paradox hidden in brightness. Outbursts reach energies that would exceed the Eddington limit if the world were built from hydrogen clouds around gentle stars. Yet the old limit was drafted for matter interacting with light in an unmagnetized arena. Here, cross-sections shrink for certain polarizations. Opacity is not fixed. Radiation can escape even when the arithmetic of old textbooks insists it should be trapped. It looks like a violation until the fine print is read. The universe is not breaking its own oath. It is following clauses that were rarely invoked before. He listens for rhythm and hears a spin that should slow at a measured pace as dipole radiation bleeds energy away. The slowdown is real, yet it refuses to be a smooth slope. Sudden leaps appear. Glitches step the period downward in an instant, as if the star gained a breath of angular momentum from a reservoir beneath the crust. That reservoir cannot be ordinary liquid. It behaves like a superfluid, threaded by quantized vortices that pin to the lattice. When many pins release together, the interior hands some of its hoarded rotation to the crust. The crust responds like a bell struck once, ringing through the magnetosphere. Then, in a different episode, a contrary event arrives, an anti-glitch. A star slows a tiny fraction faster than its trend, as if torque from without seized it for a heartbeat. Neither event belongs to the old syllabus of rigid bodies. He senses that scale itself is part of the offense. The star is 20 kilometers across, yet wraps itself in a field that can reach across light seconds with authority. Lines of that field snake outward to a light cylinder where corrotation would require impossible speeds. Beyond that cylinder, magnetism still governs. Currents stream along the lines like traffic confined to invisible highways. When stress builds, reconnection can occur at relativistic speeds. The release is not leisurely. Alphen waves carry the disturbance around the star faster than a blink, launching hard photons in a geometry that remembers the knots that broke. He writes the simplest number and stumbles over its consequence. The field strength near the surface dwarfs any contrivance born in an accelerator. It is enough to make a single photon split into two of lesser energy without needing a material target. In a laboratory, such a process is fanciful. In this environment, it becomes a shaping influence on the emerging spectrum. High-energy photons would normally scatter and energize electrons, but here they may divide or convert into pairs that join a dense, hot plasma, changing the very character of the outburst. A flare becomes a negotiation among processes that rarely meet in the same room. He contemplates temperature in a place where temperature is a blunt word. The surface can glow at millions of degrees. Hotspots at the magnetic poles can exceed that. Fed by returning currents that slam into the crust, their energy converted into X-rays that light the cavity around the star. The cavity acts as a trap for some photons and a runway for others. An observer sees a spectrum with a soft hill and a hard tail. The hill suggests a heated surface. The tail implies particles surfing on fields and scattering light to higher energies. That blend refuses to be mimicked by ordinary pulsars, whose fields are tame by comparison. He considers youth and finds another disobedience. Objects with such ferocity do not last. Their fields decay in tens of thousands of years, perhaps sooner if currents leak through crustal faults or if ambipolar diffusion reshuffles the interior. Yet they are bright in X-rays even when not flaring. The brightness is not sunlight but grief. Energy bled from a decaying field and turned into heat that reaches the surface. It is as if the star pays for its own creation by spending its inheritance every day. The sky contains ancient red giants that do little quickly. Here is an opposite, a child by cosmic standards, burning through reserves that cannot be replenished. He tests the geometry in his mind. At the polar caps, lines of force crowd more tightly than at the equator. Vacuum is not allowed to remain vacuum. Pairs appear, electrons and positrons born from photon power, and then flung outward along rails. Their motion produces radio waves in some regimes and glares of higher energy in others. The relation between the high and the low is not trivial. In some episodes, a radio shout accompanies the gamma crack. In others, silence follows thunder. The mismatch is not random. It swears allegiance to a topology he has only partly grasped. He returns to the crust because it holds a human kind of drama. Stress accumulates in slow accents that no ear can hear. Then the music leaps. The lattice loses its certainty. A fracture runs. The surface shifts by less than the thickness of a fingernail, yet the energy released could light a galaxy for an instant. If the crack couples to the magnetosphere with the right twist, entire bundles of field lines jerk and reconnect. The sky near the star becomes a pinball machine of particles ricocheting through changing pathways. He imagines standing on that surface, feeling nothing because time would end first for any instrument he tried to bring. He imagines the after effect instead, a tail of pulsed light modulated by rotation, the star ringing with its own bell note until the strain disperses. He measures expectations against the record and finds habits that remain delinquent. A burst with a clean period arrives, then a burst without it. A flare saturates detectors and is followed by a season of quiet that suggests exhaustion. Then the quiet fractures into a storm of lesser flashes that were not forecast by any tidy exhaustion curve. Classical thermonuclear models drafted for white dwarfs are helpless here. The energy source is not fusion but field. The language of accretion that explains behavior in many X-ray binaries is present only in rare cases. This engine does not need fuel from a neighbor. It needs only its own magnetism and the stubbornness of condensed matter resisting a command it must eventually obey. He closes the notebook with a hand that does not quite stop trembling. The tremor is not fear. It is the sympathetic resonance of a mind that has watched familiar limits bend without breaking. The shock is not theatrical. It is corrective. It says that the world he inhabits is larger than its most practiced metaphors. Here, gravity, quantum electrodynamics, and nuclear matter crowd the same tiny volume and hold a summit without translators. The minutes of that meeting are written in pulses and flares. Those minutes are brief and brutal and beautiful. To read them is to admit that a star the size of a city can force new definitions of what light is allowed to do. He watches a massive star prepare for silence. Hydrogen that once sang in gentle shells is gone. Helium too is a memory. The core is iron, a metal that gives no more energy through fusion. Gravity waits with old patience. The pressure at the center reaches nuclear scales, and the arithmetic grows unforgiving. Photons trapped in the core cannot carry heat away fast enough. Electrons begin to be eaten by protons, a rush of capture that makes neutrons and launches neutrinos in uncountable swarms. The neutrinos leave as if the core were transparent, and for a heartbeat, the star becomes an engine that radiates almost only in that ghost light. He marks the exact cruelty of iron. Fuse lighter elements, and energy is liberated. Fuse iron and the books do not balance. With no exothermic path, collapse proceeds. The inner core falls nearly freely, a plunge that accelerates to a fraction of light speed in a distance smaller than a continent. Matter passes the neutron drip line. Nuclei cannot keep their identity. Neutrons overflow into a sea of degenerate particles. Pressure rebounds from the strong force when nuclear densities are reached. The core discovers its stiffness, halts for a moment, and pushes outward. A shock front forms at the boundary between the inner core that has come to a stop and the outer layers that are still cascading inward. He traces the shock as it rises and then falters. Photodisintegration eats its energy, breaking heavy nuclei into lighter pieces and costing precious work. Neutrinos carry more energy out, robbing momentum. The shock stalls at a radius that would fit inside a small moon orbit. There it lingers like a decision. Turbulence grows in the stalled region. Convection blossoms. Instabilities with names that sound like waves carve patterns in the flow. The shock needs a reason to reawaken. It finds one, not in heat, but in renewed momentum from below. Neutrinos that stream from the hot proto-neutron star deposit a sliver of their power into the layers just behind the shock. That sliver is small compared to the flood, yet it is decisive. The shock is pushed again. It gains run and carries the outer layers into an expansion that will paint a nebula. A supernova is born, not as a single explosion, but as a choreographed revolt against gravity by layers of physics that rarely collaborate. He focuses now on the compact heart that remains. The proto-neutron star is a world only tens of kilometers across, glowing with tens of billions of degrees, its interior crowded with states of matter that no laboratory has contained. It cools on the timescale of seconds, a cooling measured in neutrino pulses that would dwarf the output of galaxies for a moment. As it cools, it contracts. In contracting, it spins faster. Angular momentum that once belonged to a blue supergiant must now live in a sphere smaller than a city. The figure skater draws in an arm and becomes a blur. The newborn remnant reaches rotation periods of tens of milliseconds, sometimes less, and the very act of rotation begins to sculpt its future. He reads the equation of state as if it were a new scripture. The stiffness of nuclear matter decides how the remnant stands against further collapse. A stiffer relation permits a larger radius for a given mass. A softer relation compresses more tightly. Each choice alters how the star rings after the bounce, how it traps heat, how it manages the currents that will emerge as the magnetic field asserts itself. For some masses, the remnant is stable and settles into existence. For others, a delayed collapse proceeds, and a black hole claims the role of final object. In between those outcomes is a narrow country where an ember survives, not gentle and not quiet. He listens for motion inside the core. The rotation is not uniform. Differential layers shear past one another. Turbulence rises in zones like weather in a planet with no sky. Shear stretches any seed magnetic field into bands that wrap the core with direction. Even without a formal dynamo, amplification occurs because motion refuses to remain tame. The field that results will be a character in every scene to come. For now, its presence is a pressure in equations and a collection of lines that thread the newly formed crust. He examines the crust as it begins to take shape. At the surface, the density declines from nuclear to something merely absurd. Ions arrange themselves into a Coulomb lattice, a crystal forced into being by the balance between mutual repulsion and the pressure from outside. Electrons wander as a sea. Deeper down, nuclei acquire neutron skins, then the skins join, and matter flows toward uniformity. Between those regimes lies a bestiary of shapes that specialists call pasta, sheets and rods that minimize energy in a compressed buffet. This architecture matters, not as a curiosity, but as a map that will guide where stress prefers to accumulate and where current will find the least resistance. He marks the kicks that eject the remnant from its nursery. Asymmetries in the explosion hand the compact star a velocity. Hundreds of kilometers per second are common. In some cases, the speed exceeds the escape from the parent cluster. The remnant becomes a wanderer, a small, heavy traveler that will cross the galaxy for ages. Its path is not random art. It is written by tiny imbalances in a chaos of falling and rising material. The kick tilts the spin or sets it, and that tilt will matter when light is beamed from scars on the surface. He studies fallback, the quiet rain that follows the violent storm. Not all material joins the expanding remnant. Some lacks escape speed and returns. That returning matter forms a brief disk or a thick flow, its fate shaped by the still forming magnetic field. If accretion proceeds, the remnant gains mass. The added weight can nudge the star closer to instability. The incoming material also carries angular momentum, either reinforcing the spin or struggling against it. In rare arrangements, that fallback is enough to ignite late-time power and late-time symmetry breaking. The newborn object learns that its biography is not just written in the instant of bounce, it continues in the aftershocks. He considers the role of neutrino opacity, not as a technical note, but as a shaper of temperament. The rate at which neutrinos stream from the core dictates cooling and contraction. A slower exit makes a puffier remnant that lingers at larger radius. A faster exit carves the star more tightly and deepens gravity's well. That well decides how tightly light is redshifted and how near to the surface the last scattering for radiation will occur. Observers will later read those choices in pulse profiles and spectral hardness. The choices were made in seconds, then encoded for thousands of years. He examines composition with care. The outer layers are a workshop for the heavy elements that human bodies use in tiny quantities and industries use in lavish ones. Neutron-rich outflows, pushed by neutrino heating and wrapped by rotation, assemble nuclei that rise beyond iron. Some of that bounty is flung into the nebula, anchoring future planets with cores that can hold dynamos. Some of it falls back and becomes part of the crust, adding impurities that strengthen pinning and thicken the story of glitches that will one day arrive. The remnant is not a sterile stone. It is a processed world whose chemistry remembers the manner of its birth. He measures the gravitational field one more time, as if numbers could cure astonishment. A mass comparable to the Sun is squeezed into a sphere 20 kilometers in diameter. The escape speed at the surface is a significant fraction of light speed. Clocks at the surface would tick more slowly than those far away by factors that make everyday timekeeping quaint. Light leaving the surface loses color, its energy paid as a toll to curvature. These facts are not decorations. They set the stage for every observational signature. When a hotspot rotates into view, its light is bent, its time stretched, its polarizations altered by the journey through a magnetized vacuum that behaves like matter. Reach the surface with a probe, and it would weigh mountains. No probe will reach. Imagination must do the heavier lifting. He allows the last images to settle. A core imploded, a shock revived, an ember survived. The outcome is compact enough to vanish behind a thumbnail at arm's length, yet dense enough to challenge the grammar of matter. Its rotation was not an afterthought. It was an inevitability carved by symmetry and conserve laws. Its crust was not a skin only. It was a device for storing tension. Its field was not a garnish. It was a scaffold on which energy would later be hung and violently removed. Gravity crushed the ember, and in doing so prepared an engine that does not need fuel in the ordinary sense. It will feed on stress, on misalignment, on the maturity of a field that will both guard and betray the structure it inhabits. He holds to the quiet that follows a calculation that is both precise and mythic. The numbers are clear, the sequence is sound, and yet the feeling remains that something audacious has been smuggled into existence. A city-sized object carries the mass of a star, spins fast enough to make a hummingbird look slow, and keeps a temperature that sneers at furnaces. This is not a construct that invites comfort. It invites attention. Attention will reveal the first misfires of its clock, the first adjustments of its crust, the first whispers from a magnetosphere that is learning its own shape. The birth is finished. The character is established. The stage is small. The forces are not. He opens a model of space that is not empty. The chalkboard begins with Maxwell, then adds the quiet corrections that only appear when fields become enormous. A single symbol, the fine structure constant, sits beside terms that speak of virtual pairs and higher-order diagrams. In ordinary rooms, those terms are decor. Here they are furniture. The magnetic field takes the vacuum and turns it into a medium. Photons that once ignored orientation now carry two identities that travel differently. One mode sees lower opacity, the other sees higher cost. The change is not philosophy. It changes how light escapes and what it remembers. He tests the resonance that knits matter to field. Charged particles spiral at cyclotron frequencies set by the field strength. Electrons resonate at energies that rise beyond the soft X-ray band when the field crosses the quantum critical level. Protons resonate at much lower energies, opening the possibility of delicate absorption features in the hard ultraviolet or soft X-ray range. If such a line shows, it would be a gauge of the field at the surface. If the line shifts with rotation, it would map gradients and reveal topography. The possibility hangs like a bridge that instruments are learning to cross. He sketches a fireball that does not need air. A sudden reconnection of twisted field lines releases energy into the magnetosphere as a trapped bubble of pairs and photons. The bubble is confined by magnetic pressure, far stronger than any ram pressure of escaping plasma. Temperature inside the trap rises to tens of keV. Light tries to flee, scatters, splits, and sometimes converts into pairs again. The fireball shrinks as it cools, its surface bright in hard X-rays that pulse with the rotation. The modulation is not simple. General relativistic light bending and angle-dependent opacity sculpt the pulse into a profile that contains hidden geometry. Decoding that geometry becomes a craft in which radiative transfer and curved space negotiate a truce. He considers a polar cap that never rests. Return currents crash into the surface along open field lines, heating patches that glow while neighboring regions remain cooler. These hotspots imprint a periodic signature on the emerging light. The magnetosphere above is filled with charges that do not require a surface reservoir. Pairs are born directly from the field-mediated interactions of photons. The density can approach the Goldreich-Julian value and then exceed it when cascades ignite. In such a thicket of charges, resonance scattering becomes the dominant sculptor of the spectrum. Seed photons from the surface gain energy while climbing the ladder of repeated collisions with mildly relativistic electrons. The result is a high-energy tail that would not exist without the field's grip. He writes the equations of magnetothermal evolution and lets them run in his head. The crust's conductivity is anisotropic, much higher along field lines than across them. Heat prefers paths the field allows. A buried tangle of currents decays by two primary mechanisms. Hall drift moves energy through the crust like a sideways transport that can shuffle configurations without much loss, while ambipolar diffusion in the core rearranges charged components in response to magnetic stress. The decay releases heat that percolates to the surface, feeding persistent X-rays. The field is both source and sink, both scaffold and fuel. Its long decline is punctuated by moments where topology changes abruptly. Those moments are visible as flares. He returns to the knot that precedes the scream. Field lines wound by differential rotation and crustal shifts accumulate twist. The twist stores energy and forces currents to flow through the closed magnetosphere. The greater the twist, the thicker the plasma. When a threshold is reached, a reconnection event snaps part of the structure into a simpler shape. The release is sudden. Alphen waves ride the lines and communicate the change across the magnetosphere in a whisper of time. The Earth's atmosphere reacts to these events across gigantic distances. Ionospheric layers alter their electron densities when a high-energy wavefront arrives. Technology notices, even when the human eye does not. He inspects vacuum polarization as an observable rather than a clever footnote. A photon's polarization vector rotates while crossing a region where the index of refraction depends on the field orientation. The rotation can continue until a resonance is breached, at which point polarization modes exchange characters. This mode conversion bears a distant literary resemblance to neutrinos changing flavor in a star. The comparison is half a metaphor and half an invitation. If a polarimeter records the swing of polarization angle across energy bands, the dance can be inverted to reconstruct the structure of the magnetic field and the density of charges in the scattering layer. The diagnostic is exquisitely sensitive and therefore exquisitely promising. He watches light face an altered menu of fates. Photon splitting takes a single high-energy gamma and divides it into two with lower energies. The process prefers certain initial and final polarizations, leaving fingerprints on the spectrum that no other pathway can counterfeit. Pair production in a magnetic field creates electrons and positrons without any target nucleus, provided the photon exceeds a threshold set by the field geometry. Once born, the pairs radiate synchrotron light while curving tightly along the lines. The result is a cascade that redirects energy from the highest bands into a lacy spectrum with memory of the geometry that birthed it. He evaluates stress beyond the confines of force diagrams. The field exerts pressure that competes with matter pressure inside the crust. Where the ratio is high, the lattice can be coerced into odd alignments. Faults become inevitable. The field tries to straighten itself globally, while matter tries to preserve local integrity. When the impasse fails, brittle yield occurs, and the crust shifts by microns. The energy involved is not microscopic. The difference between a stressed and a relaxed configuration can reach into the budget of a small galaxy's typical starlight for the instant it is released. The flare that follows is not the whole story. A series of quasi-periodic oscillations can ride the tail, hints of seismic modes of the star that ring through the magnetosphere. Those oscillations, if measured with fidelity, are asteroseismology, with gravity at the scale of cities and magnetic intensity at the scale of myth. He turns to the light cylinder, where corrotation would require speed equal to light. Inside that cylinder, field lines are largely closed. Outside, they open to infinity. The interface is not polite. Wave energy can be launched along open lines into the broader magnetized plasma around the star. Some disturbances might survive as magnetosonic pulses traveling far enough to rattle nearby clouds. Others may dissipate locally, building a nebular cocoon that glows faintly in radio frequencies. The existence or absence of such halos becomes a test of how energy escapes and in what form. He explores the idea that the field can erase its own evidence. If reconnection simplifies the geometry, the optical depth to resonance scattering drops. The persistent emission softens. Spin-down rate changes follow, not because the star forgot how to be a dipole, but because the effective lever arm for torque has altered with the twist. Observers sometimes see a brighter phase in hard X-rays, linked to a steeper spin-down, then a return to calmer flux with a gentler break. The pattern reads like cause and effect in slow motion. It is not the entire tale, but it is a page that can be trusted. He weighs the limit of pressure for a photon gas in such fields. Traditional Eddington balance expects Thomson scattering to dominate the exchange between radiation and electrons. In a magnetized vacuum, the cross-section splits by polarization and pitch angle. The outcome is an anisotropic pressure that can permit super-Eddington luminosities along favored directions without driving material from the surface. The apparent paradox resolves under scrutiny. The star does not break a law. The law had clauses rarely called upon. He lines up predictions that instruments can chase. A pulse profile that changes shape with energy should betray energy-dependent opacities. A polarization fraction that rises with photon energy should confirm mode-selective escape. Spectral cutoffs that shift during flares can speak to pair creation thresholds moving as magnetospheric densities evolve. A quasi-periodic note in a flare tail can identify a torsional shear mode of the crust. Each signature is a key. The keys open doors to quantities that cannot be measured any other way, such as shear modulus at nuclear densities and the degree of twist in current-carrying bundles. He ends by considering what the word field means at these strengths. It is not a set of lines in a textbook. It is a material participant. It shapes heat flow, claims volume, resists change, stores energy, sets direction, and rewrites what transparency means. It can impersonate pressure, act as a spring, and declare a preferred geometry for matter to occupy. It ties the smallest quanta to the largest curvatures in a room no wider than a county. When it relaxes, the galaxy can hear. When it tightens, time seems to lean forward, waiting for the inevitable failure that will teach the next lesson. He studies a surface that behaves like stone, yet carries pressure beyond any mountain. The outer kilometers are a crystal forged by gravity, a lattice of iron and neutron-rich nuclei, arranged with a patience that only cold and compression can enforce. Electrons drift through as a sea, lending the crust its stiffness and its ability to carry currents that thread from pole to equator. In that lattice, defects gather like secrets. Impurities left from the birth stew, dislocations born of stress, regions where nuclei adopt pasta shapes to economize energy. Each imperfection is a place where force can collect, and each collection is a promise that someday silence will fail. He begins with the slowest act in the drama. Magnetic stress migrates through the star as a long tide. Hall drift shuffles currents sideways within the crust while ambipolar motion works in the deeper, more fluid core. The redistribution is not brisk, it is relentless. Lines of force strain against the lattice, urging it to adopt a geometry that would reduce energy if only matter would comply. The lattice refuses in small degrees. Elastic response buys time, shear accumulates. The map of stress becomes a cartography of future quakes, invisible until the moment arrives. He asks how strong the crust can be. At laboratory scales, iron is brittle or ductile depending on temperature. Here the rules are remixed. The pressure squeezes out voids and forces a near-perfect registry of ions for long stretches. Strength climbs to a place where numbers must be spoken slowly. The breaking strain is large by the measure of ordinary solids. That gift is also a hazard. When failure occurs, the stored energy is not trivial, it is titanic. The lattice holds back the star until it cannot, and then its surrender is recorded across light years in a spike that astonishes instruments crafted for more modest sky habits. He watches the first instant of a rupture and finds a physics that resembles an earthquake only at the level of metaphor. A patch yields when local stress approaches the threshold. The yield front travels, not as sound through granite, but as a magnetoelastic wave that couples directly to the surrounding magnetosphere. In that coupling lies the bridge between a millimeter scale of motion at the surface and a global rearrangement of field lines above. The rupture is faster than thought, carried by the speed of shear in ultradense matter and by Alfvén propagation through the magnetized exterior. In less than a breath of time, a twist that had been imprisoned becomes a storm in open space. He follows the heat that rises in the wake. Friction at the fault scalds the local crust. Microcracks branch and close. The temperature climbs until photons dig their way out as a soft glow that lingers longer than the flash. Conduction is not impartial in this realm. Heat flows easily along field lines and with difficulty across them. The afterglow becomes an anisotropic signature, written by the field itself. As hours and days pass, the hotspot fades and spreads, and in that spreading observers can trace the field geometry that lies under the skin. He listens for the tones that ride the tail of the outburst. Quasi-periodic oscillations show at frequencies that range from tens to hundreds of cycles per second. Those notes are not instrumentation artifacts. They are the voice of torsional shear modes in the crust, crosstalking with Alfvén continua in the core. Some modes are global. Others are confined patches that remember where the rupture began. The pattern of frequencies carries information that equations of state tried to hide. Shear modulus, crustal thickness, and the presence of superfluid coupling all leave fingerprints on the spectrum of ringing. When the tail finally smooths, the information remains, entered into archives as proof that the star is a bell that can be struck. He considers the statistics of these failures. A single grand event draws attention, yet the record also holds many smaller slips. Waiting times form a distribution with a character that resembles avalanches in piled sand. Small shifts are common, large shifts are rare. The pattern hints at self-organized criticality, a state in which the crust lives near a threshold because the engine that stresses it never rests. The comparison is not a theorem, it is a clue. It says that the star may not need a special trigger for each event. It needs only persistent drive and a landscape of faults ready to answer. He adds a complication that gives the plot new texture. Vortex lines in the superfluid interior pin to the lattice. As the star spins down, those vortices feel a lag and a yearning to move outward. Pinning resists the migration until a limit is reached. A cascade of unpinning can suddenly hand angular momentum to the crust, producing a glitch in rotation. Such internal readjustments can alter the stress state at the surface. A quake may be primed by interior dynamics, or a quake may itself unpin vortices by jolting the anchor points. Rotation, magnetism, and elasticity do not act as separate departments. They share walls. Sometimes they share hallways. He examines how a rupture reshapes the space above the surface. The motion of a foot point injects twist into closed lines or relaxes a region that had been over-twisted. Either change sets reconnection into motion. Particles are accelerated along newly reconfigured paths and crash back into the surface at the magnetic poles, strengthening hotspots and building arches of current that are visible as hard X-ray tails. The magnetosphere is not a passive spectator. It participates as a transformer that turns mechanical slip into radiative insistence. During the minutes that follow, pulse profiles morph, polarization angles wander, and spectral cutoffs shift as the architecture settles into a new temporary order. He looks for echoes far from the star and finds them in places that should be indifferent. The Earth's upper atmosphere registers a sudden increase in ionization on the sunlit side when a giant flare arrives, then quiets as the storm passes. Planetary magnetospheres ring like drums struck from across the void. Even spacecraft designed for other duties notice that their detectors pulse in sympathy with an episode occurring thousands of parsecs away. These terrestrial reactions are weak compared to the star's violence, but they are markers that an invisible thunderhead crossed interstellar space and stepped briefly into the neighborhood. He studies the footprint a quake leaves on pulse timing. The rotation period may jump or drift in a manner that announces a transfer of stress between deep and shallow layers. In some cases, a temporary increase in spin down follows, as if the magnetosphere has gained a larger lever arm for braking due to a new twist configuration. In others, the braking softens. Both behaviors can live in the same object at different times, arguing that the crust is not a uniform drumhead but a continent with provinces that fail differently. He allows room for plastic flow, the slow cousin of fracture. Not all stress relief happens in a single bang. Under certain thermal and magnetic conditions, the lattice may creep. Footpoints move in millimeter-per-day increments, feeding the magnetosphere with a steady diet of twist rather than sudden mouthfuls. The output, then, is a quieter increase in persistent brightness, a spectral hardening that can last weeks, and a pattern of microbursts rather than one monocle spike. Plastic episodes can load the system for a later quake. A quake can also reset conditions so that plastic relief becomes briefly favorable. The alternation writes a longer rhythm than any single event contains. He does not forget the chemistry that shares responsibility. The crust is dirty, with impurities produced in the supernova's forge. Those impurities change conductivity and strength. They fork the path of heat, pin vortices more or less strongly, and change where minor faults become major ones. Even the pasta layers that solve nuclear forces with bizarre geometry carry consequences for slip planes. It is a reminder that the poetry of a quake is made from prosaic details at the scale of femtometers and microns. In this domain, beauty and mechanism are not enemies. He imagines the star at rest after a storm. The hotspots cool. The pulse profile returns to a familiar shape, although never quite the same shape as before. The crust holds new scars that are not visible but are very real. Microstructure has been altered. Dislocations have multiplied. Pinning landscapes have changed. The next cycle of stress will fill these altered basins in its own time. When it does, a different fault may fail, or the same region may give again, because weakened rock fails more readily. Prediction remains difficult, not for lack of models, but because complexity is a character trait of this material under these forces. He stands back and sees a machine created by the most basic laws given extravagant conditions. A crystal under extreme pressure, a magnetic field determined to reconfigure itself, and rotation that ties deep fluid to shallow solid in a dance no artisan could choreograph. The scream of the crust is not noise. It is information. It says that matter has limits, and that those limits are negotiated in real time by a star that does not ask permission to enforce them. His hands rest on the console, while the last data from a recent flare scrolls by. He reads the numbers as if they were lines of a poem whose meter is stress and whose rhyme is release. The final value fades. The room returns to its quiet hum. Somewhere, a lattice prepares its next answer. He turns the lens outward to the space that does not qualify as space. From the surface to a few stellar radii, emptiness is threaded with law. Lines of force rise like harp strings from the crust, loop over the poles, and dive back in arcs that remember where they began. Between those arcs hangs a corona, not of gas in any terrestrial sense, but of pairs and photons caged by magnetism. The cage is a geometry, yet it behaves like weather. It stores stress, releases it, and then rearranges with a fatigue that fools no one. He begins with a current that should not be there if the field were content to be simple. Twisted loops demand charge to maintain themselves. The magnetosphere answers by pulling electrons and positrons from nothing into presence, a cascade fed by polar gaps where electric fields briefly remember how to accelerate. Particles born there spiral with energies that make the word speed timid. They follow rails that give no permission to wander, radiating light that betrays their curvature. The radiation hardens into a tail of X-rays that does not belong to a quiet star. It belongs to a circuit that learned how to keep itself alive. He watches a sheet form at the equator, a plane where opposing field directions are pressed together by rotation and by the stubborn will of the twist to straighten. The sheet is thin as thought and long as an orbit. It refuses to remain calm forever. Tearing modes seed themselves along it like stitches that were pulled too tight. Islands of magnetic flux pinch free as plasmoids, each an encapsulated knot that rushes outward. Between the islands, electric fields rise along the local direction, a rare place in which charged particles are allowed to gain energy not by random encounter, but by direct acceleration. The magnetosphere uses this brutality sparingly, then delights in the result. He follows one plasmoid as it runs. It travels along open field lines toward the light cylinder, where corrotation would ask too much. There it meets a boundary between controlled and wild, between closed loops and open roads. The crossing excites waves that carry information about the interior to distances where clouds might hear. If a surrounding nebula exists, the arrival slams a shock into the tenuous medium and encourages it to glow. The shock can launch a synchrotron maser, a quick bark in radio frequencies, a signal so short that a heartbeat would envy it. The act is opportunistic and cruelly efficient. He returns to the region just above the poles. There, return currents complete the loop by striking the surface and heating patches into existence. Above those patches stands a column of charge so dense that light does not escape without negotiation. Photons rise and are forced to swap energy with electrons that drift along the field. The repeated encounters push some photons uphill into harder bands. Others are diverted into favored directions. The column becomes a lens, an anisotropic device that sculpts the pulse into a braid of peaks and hollows dependent on energy. The braid changes with every reconfiguration of the corona, and instruments learn to treat the pulse profile like a weather map drawn in light. He listens to the silent language of polarization. Each photon carries not just energy but an orientation. The orientation rotates as the wave crosses a region where the vacuum has been persuaded to stop pretending to be empty. Near the star, modes separate and then mix at a resonance where density and field strength conspire. The magnetosphere prints this choreography onto every burst and every persistent glow. When a storm erupts, angles swing, fractions rise. The change is not decoration, it is a seismogram of field geometry recorded without touching the object. He watches the storm itself begin, not with a bang but with a seed. A foot point on the surface moves by a distance so small that any measuring rod would be embarrassed to report it. That motion injects fresh twist into a closed region. The twist forces current into paths that had been empty. Where the density of charge cannot keep pace with the demand, electric fields grow along the lines. Pair production answers the hunger, and soon the circuit is bright with new participants. The pressure of this crowd pushes the field toward reconnection. When the moment arrives, the change is abrupt, an edit in the script that no character can resist. He pauses at the 3 acts of a giant release. First, a spike that arrives like a knife, so brief that electronics strain to render its edge. It is the initial snapping of a configuration into a lower energy state. Then a tail, long by comparison, modulated by rotation, as a trapped fireball shrinks behind the field, its surface radiating into the narrow cones where escape is permitted. Quasi-periodic notes sometimes tremble through the tail, evidence that the star rang at the same instant the corona reconfigured. Finally, an afterglow, a softening that lingers for hours or days, fed by currents that are still rearranging their agreements. The colors cool as the cage collapses, but the story remains written in the shape of the pulse. He counts the costs and finds them paid in torque. When the corona is thick with twist, the effective lever arm by which the magnetosphere drags against rotation grows. The star slows a little faster. When the storm removes complexity, the brake eases. Instruments notice these changes as gentle bends in a long plot of period against time. The plot is not monotone. It rises and relaxes. A metronome whose beat is set by magnetic architecture rather than by a single, tidy dipole. He examines the outermost regions, the zone of escape. Particles that find themselves on open lines can inherit energies that make them missionaries. They travel into the dark, carrying a piece of the storm in their flight. Some fade without incident, some strike nearby knots of gas and turn their passage into faint arcs of radio and X-ray light. The arcs reveal that even a localized riot can leave graffiti far beyond its country. With time and patience, a survey of such graffiti could map storms that were never witnessed directly. He turns to the role of inertia in a medium that most would deny has any. The corona can become charge-rich enough to carry sluggishness as a quality. When a reconnection event tries to rearrange lines, the charged population resists by its very existence. The result is hysteresis, a magnetosphere that does not respond instantly to a new boundary condition at the surface. The delay gives structure to the rise and fall of emission. It also makes prediction precarious, because cause and effect do not stand shoulder to shoulder, but follow each other through a hall that alternately narrows and widens. He notices the quiet events too small to name storm. Micro-reconnections snap like sparks along stressed loops. They are countless and usually hidden under larger behaviors. Yet the integrated heat they supply sustains a persistent glow that never truly leaves. The corona lives on this budget when nothing dramatic happens. It is a business of small margins, conducted with exquisite steadiness. The balance is delicate, and either a new injection of twist or a slow plastic migration of foot points can tip it into a visible phase without any grand catastrophe. He imagines the magnetosphere at full complexity, a braid of poloidal and toroidal components, an embroidery of charge layers, a forest of loops stacked within loops. The mathematics to describe it precisely is stubborn. Numerical experiments approach the truth with simulations where plasma is allowed to argue with field. The argument produces jets and sheets, pairs and gaps, and confirms that the simplest starting conditions refuse to stay simple. Nature likes structures that hold energy the way a stone wall holds the warmth of afternoon. In that warmth is the promise of a night that will remember the day. He returns at last to the observer's experience. A telescope sees a storm as a sudden hardening at high energies and a shiver in timing. A radio array hears a whisper or a shout, sometimes coincident with the blast in X-rays, and sometimes arriving alone, as if the corona had found a back door into the spectrum. A polarimeter records angles that swing like a windsock in a gust. Each instrument sees a partial truth. Together they outline a storm whose heart is a conversation between geometry and charge in a room the size of a few stellar radii. He lets the sequence end with the magnetosphere quieter than it began. Loops lie closer to dipolar, the corona thins, and the column above the polar caps dims. Yet, peace is theatrical. Deep under the surface, stress migrates. Footpoints will move again. Somewhere beyond the light cylinder, a plasmoid born in an earlier moment finishes a long journey and dissolves without witness. The calm is simply a frame in a film that does not stop. The magnetosphere waits with all the patience of structure under pressure, already rehearsing lines for the next rehearsal of lightning without storm clouds. He listens for a sound that travels without air. The dish stares into a patch of sky until the statistics of silence break. A spike rises in a millisecond, bright enough that brightness itself loses meaning. The computer writes a number that implies an impossible temperature, a coherence so strict that the light must be marching in step, not dribbling as thermal chaos. The sweep across frequency is not random. Lower notes arrive late. postponed by a path through electrons. The delay follows a curve that an equation with a single power can sketch. From that curve, a measure is lifted, a count of free charges along the way, a dispersed biography of the space between. He tags the burst with coordinates and waits for the next. Some sources behave like lightning that remembers a tree. They repeat from the same spot, sometimes predictably, often with moods. Others speak once and retreat into refusal. The dish learns to be patient. A night may pass without a whisper. Then an hour erupts with a choir of barks. Each bark is a millisecond or less. Within that blink, microstructure can ripple at tens of microseconds, subpulses drifting across frequency like sparks blown sideways by a wind with taste. The precision argues for a small emitter guided by a harsh geometry and a driving mechanism that prefers order over entropy. He asks the light to turn and reveal its alignment. Polarization emerges at alarming fractions. Some bursts are nearly purely linear, as if carved with a rule. Others carry a strong circular twist that hints at propagation through magnetized plasma. The angle can rotate with frequency in a way that allows a second integral to be read from the data. Rotation measure adds a signature overlay, a statement about magnetized electrons along the path, and about fields that held direction long enough to matter. Large rotations imply an origin wrapped in a magnetized fog, where lines of force are not casual. He wonders where in the universe such tempers are groomed. The host environments range from dwarf galaxies with furious star formation to quieter spirals with patches of youth. Some locations lean toward regions where young remnants and winds from massive stars knead gas into complicated textures. Coincidences are fragile, yet proximity to nebular knots and persistent radio glows suggest that an engine lives among debris and outflow. In a few instances, a small, steady source holds near the position of the flaring. That steady ember could be a nebula, a cloud shocked and kept warm by a wind that never quite stops. The inference tempts him toward a compact engine that sheds energy in two dialects, one constant and one explosive. He calculates how sharp the radio spike must be at its birth to survive the gauntlet of plasma. The burst is a needle of coherence. That coherence would be erased by even a modestly cluttered path unless the needle was slender, the emission mechanism disciplined, and the surrounding plasma not too thick. In the best cases, scattering is minimal and the leading edge of the pulse remains steep. In others, a scattering tail smears the exit into an asymmetric shape, revealing turbulence in the near neighborhood or in an intervening screen. There are days when a repeater shows both behaviors at different times, as if the environment itself were changing, thickening with new material, and then clearing. He measures a number that boggles, the implied brightness temperature, which, in a naive view, reaches beyond any thermal process. Coherence is compelled. Charges must radiate in concert. Two families of scenarios volunteer. One family lives close to the compact object. There, charges ride curvature along tight field lines and radiate coherently, perhaps aided by bunching that instability can produce. The other family shifts the act outward. A flare launches a shell at relativistic speed. The shell meets a slower wind already flowing from the object. A shock forms. Electrons crossing the shock pump a maser at the electromagnetic mode, turning kinetic energy into an arranged radio shout. Both families can draw lines through parts of the data. Both face puzzles that sharpen rather than dull with time. He listens across bands for partners to the radio moment. High-energy eyes watch for a breeze of X-rays to accompany the bark. Sometimes a quiet tightening in X-rays arrives within seconds, a modest rise that could be the touch of returning particles or a heated patch on the surface. Sometimes no partner is seen at all, as if the radio event occurred at a distance from the star where photons beyond radio are not encouraged to escape. Non-detections speak as loudly as detections when upper limits carry weight. They suggest that bright radio barks do not require bright high-energy flashes every time. The engine can choose its outlets. He stares at a repeat source that follows a calendar only it understands. The activity opens in windows that recur with a period that hints at a companion or a wobble. The signal is not a metronome, it is a gate. Inside the gate, the source sings. Outside it sleeps. If a companion exists, The wind from that companion could modulate the ambient density and seed the shock model with rhythm. If a precession exists, the beam of a near object could sweep the observer only during certain phases of its slower turn. Both ideas are invitations to measure longer, to collect each outburst as if it were a timestamp in a diary that will reveal its pattern only when enough pages are turned. He regards a single outburst that dwarfs all others from the same sky position. The energy is too high for modest triggers. Such a day favors a model where a bulk event occurred, a crustal failure, or a sudden relaxation of twists, something that sent a slab of plasma outward in a beam with a mind. The slab met a density plateau in the surrounding wind, and the shock radiated with an efficiency that is usually hypothetical. In the milliseconds that followed, the shock coasted into thinner material, and the emissivity died. The brevity is not a limit of the engine, it is a property of the encounter. He listens harder to the fine structure. Some barks arrive in doublets or triplets with separations of a few milliseconds. The trailing element is often broader or more dispersed than the first. That pattern can be read as a series of subshocks, or as emission from different segments of a curved shock front seen at slightly different angles. Fluency in that geometry would allow the angle of the beam and the Lorentz factor of the flow to be inferred. The math is uncertain, but the invitation is clear. Timing at the level of tens of microseconds opens a map that sensitivity alone cannot draw. He studies the manner in which a signal decorates itself across frequency. Band-limited structures appear in some cases, bright islands separated by darker seas. Plasma lensing can do this, focusing some channels while defocusing others as radio waves cross thick folds in the environment near the source. Such folds could be part of a supernova remnant or outflows from the star. If plasma lenses act, then subtle drifts in the bright islands across successive bursts can betray motions in that near screen. The lensing would not create the burst, but it would play with it like a window sweating under sudden weather. He learns to treat silence as a variable. After a season of furious activity, some repeaters fall quiet for months. The quiet may be illusion, the voice simply turned away. Or the source may be in a phase where the field above the surface is smoother, with fewer reconnection events to launch shells. If the engine is a compact object with decaying magnetism, it may have cycles of stress build up and relief that project into the radio through the medium of shocks. Patience, therefore, is not passive. It is method. He follows one burst backward with imagination, from the dish through the ionosphere, across the solar system, through clouds of electrons in the local arm, skirting the warm ionized medium with its faint fluctuations, then into domains where the interstellar scintillation can twinkle the signal, then beyond into another galaxy where dust and gas congregate in spiral arms. Closer to the source, the path thickens. A remnant might encase the engine, a wind might have carved a cocoon. The shock that coughed the radio energy saw all of this as a sequence of densities and magnetic textures. The spectrum it produced and the shape of its light curve are a reply to that sequence. He waits for the next act, with an array that looks like a field of metal flowers. The flowers are tuned to catch the briefest ache of sky. Algorithms, sharpened on noise, learn to throw away terrestrial interference and hold what smells of dispersion and rapid rise. Each capture is logged with nanosecond timestamps because delay relations across instruments can fix the position to a corner of a galaxy. The ambition is quiet, almost ascetic. It seeks only a few more barks, a few more angles, a few more rotations of polarization, enough to lift ambiguity from the alternatives. He lets the lesson settle. Radio is not an afterthought. It is an honest language in which a compact, magnetized engine can speak with less self-absorption than in hard photons. The words are fast and ordered. Their grammar is coherence, dispersion, rotation, and scattering. Their rhetoric is repetition and surprise. The meaning is still being translated. Yet even in half understanding, the message is clear. Somewhere, a small object stores tension in field, lets that tension free as shells or beams, and writes 1,000 light-years away on a detector with millisecond punctuation. He listens again. The dish replies with a crisp click. The story continues in a frequency the human ear cannot hear, but the mind can learn to read. He faces a clock the size of a city that refuses to keep perfect time. The beam sweeps and the seconds march, yet in the data the march stumbles. A rotation that should decay with dignified simplicity slips forward in a blink or slackens more than its trend allows. The timing residuals, those pale lines beneath the main signal, stop whispering and begin to speak. Each deviation is tiny by human reflex, microseconds that would not trouble a wristwatch. In the language of dense matter, they are declarations. He starts with the smooth expectation. A dipole in vacuum should slow with a power law, the period lengthening as energy is bled into surrounding space. Observers fold pulses and build a template, then cross-correlate new arrivals to gather precise times of arrival. Phase connection links nights into months, then months into years. The curve that emerges is elegant. Its second derivative holds the fabled breaking index, a number that should be 3 if the star is a simple beacon. It rarely is. Indices dip below expectations, sometimes change, sometimes cannot be fit at all without invoking extra terms. Timing noise wanders through the record like weather, a red spectrum of fluctuations where low-frequency power dominates. The star is telling a story that a simple dipole cannot finish. He notes the moment the story turns urgent. A glitch arrives. The frequency of rotation leaps upward by a part in a million or so, a step that would be invisible without long patience and stubborn instrumentation. The leap is not only in frequency. The derivative shifts. Spin down steepens or relaxes, and then, in the days that follow, a recovery unfolds, exponential in some cases, piecewise in others, as if the star were a struck bell remembering its preferred note. Observers fit components with different timescales and extract a healing parameter, the fraction of the jump that decays away. The fitted numbers are not decoration, they are clues to how tightly the interior is coupled to the crust. He turns toward the unseen fluid that gives the crust its surprises. Deep within, neutrons form a superfluid, a state where rotation is carried not by bulk circulation but by arrays of vortices, each a quantized thread of angular momentum. Those threads pin to the lattice in the inner crust, rooting themselves to nuclei and defects. As the crust loses rotation to external torque, the pinned array resists change. Lag grows between the superfluid's preferred speed and the crust's enforced deceleration. When the lag reaches a threshold, unpinning cascades through a region. Vortices leap outward and repin at larger radius, handing angular momentum to the crust in a transfer as abrupt as a flock taking flight. The suddenness is the glitch. He enters the labyrinth of microphysics that decides thresholds. Pinning energy depends on density, nuclear shape, and the presence of impurities. Where nuclear pasta forms sheets and rods, pinning can be stronger or weaker than in a tidy lattice. Entrainment adds complication, an effective mass increase for neutrons dragged by the lattice, reducing the freely moving superfluid fraction. Mutual friction couples moving vortices to the normal component, damping turbulence. A cascade might be laminar or wild depending on these coefficients. Observers never see the threads, only the consequence. Yet by comparing glitch sizes, waiting time statistics, and recoveries, they sketch a map of pinning landscapes that no microscope will ever resolve. He listens for the anti-glitch, the rare cousin that slows the star a little faster in a blink. Explanations fork. One path keeps the cause internal. A sudden increase in coupling could pull the crust toward a slower interior region, subtracting angular momentum rather than adding it. Another path shifts the cause outward. A magnetosphere that thickened or twisted could increase torque so abruptly that rotation stumbles. In some cases, the deceleration pairs with changes in persistent emission, as if geometry and torque adjusted together. Distinguishing internal from external actors becomes a discipline where radiative changes, pulse profile morphing, and timing must be read in the same breath. He reads the residuals with the ear of a seismologist. Before a large event, smaller wanderings can cluster, a hint that stress in the pinning array is approaching a cooperative release. After the event, the noise floor may change, implying different coupling or changed pinning domains. The power spectral density of timing noise shifts slope. Analysts classify the walk as in phase, frequency, or spin-down rate, and measure Allen deviation to quantify stability. The vocabulary was born in metrology and repurposed for cities of nuclear matter. The application is perfect. A star can be both a clock and an earthquake machine. He examines long baselines where hundreds of glitches dot the record. Some objects favor many small steps, like gravel sliding on a slope. Others wait and deliver rare, larger leaps, like a ledge giving way. Waiting time distributions hint at self-organized criticality. The engine loads stress at roughly constant rate. Faults with a spectrum of strengths give way when their turn arrives. The distribution is not a proof of mechanism, but it is a shape that arguments must match. Over years, the mean spin down grows or shrinks, as if the magnetic architecture alternated between thicker and thinner states. Torque is not a constant. It is a mood. He imagines the vortex array not as straight threads but as a restless forest. Kelvin waves ripple along individual vortices when they unpin and move. Bundles can tangle and relax, introducing turbulence that alters mutual friction and increases effective coupling for a time. Proton superconductivity in deeper regions adds another weave, flux tubes threading the core that can interact with vortices. If vortices and flux tubes lock together, angular momentum transfer must wait for joint failure, raising thresholds and producing larger events. If they slide, frequent small adjustments result. Observables lie downstream of these microscopic choices, but they carry their scent. He looks for precession, the wobble of a top whose symmetry is imperfect. A steady, low-amplitude modulation in pulse phase and profile can betray free precession. If present, it implies a small asymmetry in the moment of inertia, or a pinned component that forces the crust into a slow sway. Quakes can reset that phase. Changing magnetospheric currents can mask or reveal it. Detecting a clean precession is difficult, complicated by timing, noise, and torque variations. Yet even a hint provides leverage on interior rigidity, superfluid pinning, and possible mountains on the surface that might seed continuous gravitational waves. He evaluates how a timing event imprints on light. Pulse shapes can alter at the same epoch as a glitch, indicating that hotspots shifted or magnetospheric geometry changed. Hardness ratios migrate for weeks, then drift back. Polarization angles move with the same sense as the torque change. These coincidences are not accidents. They are handles for disentangling internal and external triggers. If rotation changes without radiative consequence, the case for interior dynamics grows. If both change together, a quake-driven scenario gains weight. The ledger is updated in real time by telescopes that span radio to gamma, each adding a column of numbers to a single page. He asks what continuous waves might say if they could be heard. A rotating asymmetry would radiate gravitational energy, shaving angular momentum invisibly. The required mountain is small, millimeters high at most, held by a crust whose strength can support it against gravity that humbles all shapes. If such a signal were detected, it would be a direct measure of quadrupole deformation and crustal strength. For now, upper limits constrain the size of these imperfections and inform models of how much pinning and plastic flow the crust can bear before it smooths itself. He contemplates the heat that glitches might release. Unpinned vortices drag and dissipate. Crustal shifts rub and warm. The warmth could reach the surface as a subtle brightening weeks later, a soft X-ray rise that hides within variability unless watched with focus. In objects where persistent emission is strong, the contribution may be marginal. In quieter cases, the thermal echo may be discerned. A detected echo would weigh the frictional path and the depth of the event. Silence would favor shallow rearrangements or rapid diffusion that spread the heat too broadly to notice. He turns to method, to the craft that makes such small stumbles visible. Phase-coherent timing demands that no cycle be lost in months of observation. Templates evolve as profiles change, but evolution cannot be allowed to masquerade as phase drift. Bayesian frameworks weigh models that include step changes in frequency and derivative against those that prefer noise with a given spectrum. Glitch hunters write code that scans residuals for the subtle beginning of a step, then alerts networks to increase cadence. The equipment is modest by the standards of flagship missions, often a single radio dish under a sky that looks indifferent, The results are precise enough to indict or absolve entire classes of microphysics. He ends on a truth that carries no drama but much power. Rotation is the simplest observable a compact object offers. It is a metronome by which nearly everything else can be compared. When that metronome falters, it invites a hand under the surface. Vortices confess their pinning, flux tubes hint at their grip, crustal faults admit their thresholds, magnetospheres reveal their leverage. The city-sized clock keeps time with a second hand that occasionally jumps. The jump is never an error. It is the star's way of telling anyone who will listen that rigidity and flow are partners, that torque has a biography, and that even in the strongest matter known, endurance is a negotiated art. He approaches the interior as if entering a cathedral where pressure is prayer. The outer kilometers give way to strata that defeat analogy. Density climbs until numbers sound theatrical. Electrons join with protons and surrender identity. Neutrons dominate, yet they do not behave as an ordinary liquid. They choose the clarity of a superfluid, a state that carries rotation through quantized threads rather than whirlpools. Protons, the minority, become a superconductor, expelling field from their bulk in patches and trapping it in thin tubes where magnetic flux is permitted to live. The two orders coexist like interlaced choirs, each with its own discipline, each sensitive to the slightest change in stress. He lingers at the crustal base where matter rehearses impossible shapes. Nuclei stretch into rods, spread into slabs, punctuate space as bubbles and tubes. The architecture earns a domestic name that hides its severity. Pasta is a landscape tailored by the strong force and the tyranny of compression. It decides how vortices from the neutron sea attach or slip. It sets the placement of impurities that break symmetry and add memory to the lattice. It offers pathways for currents that would otherwise struggle to find a route. In this gallery of forms, mechanics is written in geometry, and geometry is written in survival. He follows a single vortex line as it threads downward. The line is a filament of lost rotation, a conduit by which the superfluid shares its angular momentum with the world beyond. It senses the lattice above and the superconductor below. Where proton flux tubes rise from the core, the vortex feels their presence as obstacles or guides. The two families can pin to one another, or they can slide with friction that depends on temperature and microstructure. These choices matter to everything that clocks and flares. A forest that tangles transfers torque reluctantly and then all at once. A forest that glides bleeds torque in quiet continuities. He places a flux tube beneath the microscope of imagination. It is a thread of magnetic intensity imprisoned by superconducting order. Within it, protons give up pairing and allow field to coexist with matter. The tube is narrow, packed with energy, and able to push on neighbors by tension along its length and pressure across its radius. A bundle of such tubes stores magnetic stress inside the star where no instrument can look. When the bundle migrates or rearranges, it changes the shape of the external field without ever appearing on the surface. The hidden heart is not a vault that preserves. It is a loom that weaves. He listens for the soft music of neutrinos. Cooling begins in the earliest seconds and continues for ages, according to which channels are open. If the composition admits a certain balance of particles, direct Urca reactions proceed and carry heat away with brutal efficiency. If not, the slower modified channels dominate, and cooling is gentler. Superfluidity alters the script. Pairing suppresses some reactions, and then, paradoxically, creates bursts when pairs form and break. The timing of these phases determines whether the surface will glow more brightly in youth or go dull early, whether outbursts will fade from a higher or lower baseline, whether heat from buried currents can break through the insulating layers. He writes the equation of state as if sketching the outline of an unknown animal. Stiffness dictates how much matter can be supported without yielding to collapse. It sets the radius for a given mass and the gravitational redshift that every photon must pay. Deep inside, other species may enter the conversation. Muons can share momentum when electrons grow too energetic. Hyperons may appear if density surpasses their thresholds, softening the matter and changing sound speeds. Somewhere at greater depth still, quarks might deconfine into a new soup that obeys a different simplicity. Each possibility alters mode frequencies, heat capacities, and magnetic transport. None are visible to telescopes, yet all are audible in the star's behavior when stress takes the microphone. He pictures magnetic architecture that refuses to be planar. A poloidal skeleton threads from pole to pole while a toroidal band wraps the waist. Alone, each geometry is unstable. Together, they can persist. A twisted torus buried so deeply that only hints of its presence are seen in the timing of flares and the lopsidedness of torque. The interior field can bully the matter into a slight distortion, a prolate or oblate figure that tries to precess and is constantly damped by the viscosity of superfluids and the friction with flux tubes. If the distortion is large enough, the star hums in gravitational waves too faint for current ears, yet strong enough to bleed a fraction of angular momentum silently. He tracks heat as it tries to escape. Conductivity prefers the direction of field lines. Lateral transport is grudging. A pocket of warmth, born from the decay of buried currents, will search for a vertical path and may surface near a pole rather than directly above its source. The journey is mediated by electrons scattering on impurities and on phonons in the lattice, by the presence of dripped neutrons that share energy imperfectly with the normal component, by a mantle of pasta that scrambles straight avenues into mazes. When a telescope records a hotspot that grows and wanders before fading, the map of that motion is the projection of heat flow through stratified matter. He runs the slow clock of magnetic evolution. In the crust, Hall drift moves energy without much loss, like a sideways tide that shuffles patterns and gathers small scales where dissipation can finally act. In the core, ambipolar diffusion rounds corners in the flux bundle, responding to pressure imbalances that magnetism creates. The timescales depend on temperature and composition. When the star is young and hot, motion is faster. As it cools, the interior freezes into obstinacy. Outbursts draw their budget from this slow banking. The field decays by turning its order into heat and by rearranging its topology. The light seen from afar is a receipt for both. He attends to oscillations that never reach a microphone but leave signatures anyway. The interior holds Alfvén spectra and shear spectra that couple through the crust-core boundary. A flare can tap these modes, ringing the star in patterns that emerge as quasi-periodic train tracks in a high-energy tail. A quieter period can excite them through differential rotation, producing wandering drifts in pulse phase that masquerade as noise. If the frequencies and damping times are decoded, they confess not only the stiffness of the crust, but also the superfluid densities and the strength of coupling across boundaries no probe can cross. He contemplates the boundary itself. At the transition from the liquid core to the solid crust, the properties of matter change faster than any instrument can walk. Waves reflect and refract. Vortices that are smooth in the core must adapt to pinning landscapes in the crust. Flux tubes that glide in superconducting regions must encounter normal layers where they can expand and exchange energy in new forms. The interface is a marketplace where momentum, heat, and magnetic stress trade ownership. An episode that seems surface-borne can have been priced and purchased at this counter hours earlier. He returns to the smallest scales, because there the star keeps secrets with highest fidelity. Coherence lengths for superconducting order, penetration depths for magnetic fields, scattering lengths for quasi-particles, all enter the macroscopic behavior through coefficients that appear in averaged equations. The averaged equations produce elegant curves and predictions, yet a change of 10% in a microscopic parameter can lengthen a cooling epoch by centuries or alter the amplitude of a mode by a factor that determines whether a signal is seen or lost in noise. The hidden heart is not smooth. It is granular in principle and only smooth in summary. He walks once more through the internal city. Streets of flux tubes cross avenues of vortices, districts of pasta neighbor, seas of uniform nuclear fluid. Above, the lattice holds dislocations like memories. The engine that the galaxy fears is not a single machine, but a union of orders. Superfluidity offers inertia and suddenness. Superconductivity offers memory and stiffness. Composition offers grace or burden to the escape of heat and the migration of field. Each star chooses different weights on the same scale. Each one learns a unique dialect for expressing stress. The dialect is transmitted through timing stumbles, flare morphologies, polarization angles that remember how light traveled, and baselines that drift as the core rewrites its own map. He lets the lights dim on this interior stage. There is no view in human sense, only inference stacked upon calculation, stacked upon measurements that are painfully indirect. Yet certainty is not required for reverence. It is enough to know that in a sphere 20 kilometers wide, a phase diagram of nuclear matter is being traced with the confidence of nature. It is enough to admit that the heart no instrument can see is the author of the star's exterior moods. The hidden part does not remain hidden out of cruelty. It remains hidden because depth is the price of such concentrated truth. What leaks outward is instruction. What stays within is the reason the instruction carries weight. He lays two blueprints on a steel table. Each promises the same tower of magnetism. Each draws its strength from different beginnings. One blueprint speaks of birthright, of a field wound in the first seconds by a storm of rotation and convection. The other speaks of inheritance, of a progenitor star that guarded a mighty configuration through its luminous life and bequeathed it to the core when the light went out. Both plans can raise a magnetic citadel high enough to terrify space. Only one was chosen by any given star. He starts with the plan that favors heat and haste. A newborn remnant spins with periods short enough to make a city blur. The interior is not quiet. Neutrinos carry energy outward in torrents, leaving behind gradients that drive convection as if the core were a pot under a fierce flame. Hot matter rises and cool matter sinks in fat plumes that shear and curl. The rotation aligns some flows and deflects others. In the chaos, an organized conspiracy emerges. A dynamo grows. Seed fields, perhaps no stronger than those in a well-behaved pulsar, are stretched, twisted, and folded. Each fold doubles intensity. Folding repeats until magnetic back reaction stiffens the fluid and arrests further growth. The timescale is seconds. The outcome depends on the rotation rate, the vigor of convection, and the size of the region where both overlap. He traces the signatures this scenario would leave. If the field is born from motion this way, the strongest cases require extreme spin at birth. Periods near a millisecond give the dynamo a wheel to grip. Such spin carries a budget of rotational energy that can be spent on the nascent magnetosphere, driving winds strong enough to shape the surrounding debris. A remnant nebula, energized by a central engine, may glow for years, with a persistence that outlasts ordinary afterlife. The dynamo insists on a correlation between early rotation and later magnetism. Observers who can reconstruct natal periods from remnants and fitting models might find that the loudest magnetic voices began life in the fastest rooms. He sets the other plan beside it, the map of inheritance. Massive stars sometimes wear surprisingly stable surface fields. The patterns do not match what is expected from shallow envelope convection. They look like relics, large-scale dipoles whose roots run deep. A fossil field can resist the forgetfulness of turbulent interiors if it finds a stable marriage of poloidal and toroidal elements. When the core collapses, magnetic flux is compressed as the radius shrinks by orders of magnitude. The same total flux concentrated into a smaller area yields intensities that tower. A field that draped a main sequence core in quiet strength becomes a field that dominates a city-sized remnant. The process is simple multiplication by geometry and conservation. He examines what this path would imply. A correlation should exist between certain classes of progenitors and the compact objects they spawn. Chemically peculiar O and B stars with stable fields would then seed remnants predisposed to violence. Clusters where such stars are common should yield more magnetized remnants per 1,000 births. The fossil plan suggests that the remnant did not need a furious spin to become what it is. Strong magnetism and moderate rotation can coexist at birth, freeing the newborn from an early wind whose power might have otherwise swept too vigorously. He listens for the counterarguments, whispered by both sides. The dynamo plan objects that inheritance requires remarkable stability over millions of years in a star that convects in its core and rotates with differential impatience. The fossil plan replies that dynamo saturation cases need natal spins so fast that centrifugal effects would reshape early light curves and leave traces in the remnants that are not always seen. Each points to data that is persuasive but not decisive. Each invites better statistics and cleaner forensics. He opens a third folder that combines the first two without shame. Hybrid histories are allowed. A moderate fossil field in the progenitor can seed a configuration that a brief dynamo then exaggerates during the violent seconds of birth. The newborn field can later be tuned by slow internal drifts that both scenarios share. The interior forgets who was stronger in the first minute. It remembers the topology and the distribution of energy locked beneath the crust. He measures environments where the child grew up, because surroundings leave their own clues. Remnants that live inside young star-forming regions suggest youthful parentage for at least some cases. In such neighborhoods, massive stars crowd and die in overlapping epochs. A fossil plan thrives where magnetic main sequence stars were abundant. A dynamo plan asks only for rotation and thermal gradients, things any massive collapse can offer under the right spin. If a remnant lies alone in an older field, the forensic trail is colder. The engine's biography must be read from the engine itself. He weighs the relevance of kicks. Asymmetric ejection during collapse can launch the remnant at hundreds of kilometers per second. If the source of asymmetry tracks with intense convection patterns or with sloshing in the stalled shock, then the dynamo's vigor might correlate with the vigor of the kick. If intrinsic field geometry in the core influenced angular momentum flow before collapse, then inheritance could be linked to certain kick directions. Observers stacking velocities and field estimates might find a trend. For now, the scatter is large, and trend hides behind noise. He considers spin-down histories not as a bookkeeping task, but as evidence. A vigorous dynamo at birth, accompanied by a fast period, would imply large early torques and rapid lengthening of the day. If the torque was strong enough, it could power wind nebulae with distinct morphologies. If field strengths decay on timescales of 10,000 years, the early epoch may be bright enough to be found in old archives of sky surveys. The absence of such nebulae around many candidates tilts the argument one way. The presence around a few tilts it the other. Balance returns to the table. He returns to the mathematics that encourages inheritance. Stable magnetic configurations in stars are rare among the infinite sketches that fluid dynamics permits. Yet special combinations of poloidal and toroidal elements can trap themselves in mutual support. A collapsing core that preserves such a combination will deliver a remnant with energy stored in a pattern that refuses to decay quickly. If later motion builds stress in the crust, the stored energy can feed it. If the configuration is too simple, the remnant becomes more ordinary. If too tangled, instabilities force it towards simplicity on short timescales. The fossil plan depends on a pre-collapse serenity that some stars may achieve. He tests the opposite dependency for dynamo efficiency. Efficient dynamos prefer Rossby numbers less than unity, where rotation sweeps faster than convective overturn. The early remnant offers this condition for brief minutes. The plasma Prandtl number, the scale at which viscosity and magnetic diffusion argue, decides the size of structures that the dynamo favors. Unknown coefficients become decisive. The argument is not lack of principle, it is lack of numbers carved from experiments none can perform. Theorists trim parameter spaces and surmise that only certain combinations can deliver the very highest fields. Those combinations require youth that borders on extremity. He allows a clue from decay to enter the room. Field strength recedes with time, warmed into persistent X-rays by magnetothermal evolution. The rate of retreat might depend on where the energy sits. If much is buried in the crust, Hall drift can accelerate topology changes that lead to heating and to flare-prone behavior. If much is caged in the core, the decay is slower, the heat lower, and outbursts rarer. An inherited configuration that dominated the core would yield a different life arc from a dynamo field that left more of its budget in the crust. The statistics of quiet and noisy lives among known objects nod toward this logic, even if they refuse to bow. He moves last to what a decisive test would look like. A measurement of polarization across broad energy ranges during quiescence and during storm could map field geometry above the surface with enough detail to back out whether a strong toroidal belt lies beneath. A census of host environments with precise ages and metallicities could sharpen the association with certain progenitor classes. Gravitational wave limits on early spin-down could reject the fastest natal periods for some individuals. A fortuitous nearby infant remnant, caught within years of birth, could reveal the wind nebula a dynamo craves or the quiet strength a fossil field prefers. Instruments exist that can attempt parts of this program. The rest is patience and luck. He lets the table clear itself in his mind. Two plans, both plausible, both proud. Perhaps nature chose both across a population, each star a case study in how initial conditions negotiate with universal laws. Some were born to be fierce because their first seconds offered the perfect storm of rotation and heat. Some inherited their ferocity as a legacy written in the hearts of brilliant ancestors. None can rewrite the rules once set. The later light curves, the late storms, the slow fading of heat are consequences rather than choices. He stands in the quiet room and feels no need to declare a single victor. The sky is large enough to hold two truths that build the same tower from different stones. He sketches an orbit that never knew safety. A small world circles a compact star whose light is mostly warning. At aphelion, the sky is harsh. At perihelion, it becomes a metal song. Charged particles pour along invisible rails and comb the planet's magnetic field until the field folds like wet paper. If the planet owns a dynamo, it helps for a moment. Then the storm compresses the shield to a height that aircraft would mock, and the upper atmosphere stands naked. Molecules begin to break. Atoms rise as ions and do not come home. He builds the air from scratch to watch it be unmade. Nitrogen and oxygen seem durable at first glance. Hard photons disagree. They split bonds and write new chemistry. Oxides of nitrogen bloom in chains that eat ozone with unemotional efficiency. With ozone gone, ultraviolet becomes a rain of knives that reaches the ground. If there were oceans, their surfaces would flare with fluorescent scars. If there were forests, their upper leaves would brown, while deep canopies might endure a little longer. On nightside hemispheres, the aurora would not be art. It would be weather, sheets of green and red that do not fade. He follows the escape routes. The simplest path is heat. A flash raises temperatures at the exobase until the mean speed of light molecules exceeds escape. Hydrogen leaves first, dragging some heavier partners through collisions. The second path is non-thermal. Ions pick up energy from electric fields that tie sky to ground and sprint along open field lines into space. The third path is sputtering. Fast particles from the star slam into the upper air and kick atoms loose in cascades. Each path has operated in the solar system to small degrees. Close to this compact engine, all three become policies rather than exceptions. He calculates pressure makeups that could last. Thick carbon dioxide might survive longer than oxygen-rich mixtures because heavier molecules cool more effectively through infrared lines. Yet heavy does not mean safe. A single giant flare could erode decades of recovery, draw the ionopores downward, and open a conduit for loss. If the planet's interior is generous, volcanism could replenish some inventory. If it is stingy, every storm tightens the future. The world becomes a ledger of arrivals and departures. In that ledger, deficits dominate. He considers a moon around a quiet giant that wanders too near the star. The moon shares the magnetized shock of its primary and adds its own troubles. Induction builds currents in salty oceans, if any exist. Currents that heat and stir. Tidal forces from a nearby compact object would be small unless the orbit is desperate. Electrical tides, however, can rival mechanical ones. A conductor moving through a fierce field knows a drag called unipolar induction. The drag grinds orbits down and feeds heat into mantles with patience only gravity understands. Over millions of years, the energy budget for geology changes sign. A world that should have cooled becomes restive. He lays out the terrain of visibility. A planet that bears this lash will signal in lines no tranquil world would favor. Nitric oxide glows in infrared bands when the upper atmosphere is wounded. Hydroxyl detaches from water and writes a faint sign between dust lanes. Radio noise rises as lightning declares itself not in clouds but in ionospheric sheets. Exospheres extend in cometary tails downwind from the star, neutral sodium and potassium scattering starlight in fragile veils. Transit spectroscopy could catch these shreds and wonder whether life breathed beneath them or whether chemistry alone is telling the whole story. He is careful with the temptation to declare barren verdicts. Worlds adapt in ways that do not flatter human expectations. Subsurface habitats can thrive under meters of rock where fast particles spend themselves unglamorously. Oceans with depth shrug off ultraviolet tantrums. Ice crusts cover seas and filter hard light into soft blue that microbes could love. Caves fill with air that is replaced not from sky but from stone. In such shelters, time becomes a patient alchemist. Even frequent ionizing surges would be a clock, not a guillotine. He maps a habitable zone that is not the usual ring. Around a compact engine, the conventional measure of warmth fails. The dominant variable is not stellar flux, but security. A safety zone hangs far beyond the radius where liquid water could be supported by heat alone. The zone's interior edge is written by the reach of storms, by the energy that arrives in particles rather than photons, by how often a flare exceeds thresholds for chemistry and escape. The outer edge is drawn by practicality. Beyond a certain distance, a planet receives so little input that only internal heat can keep an ocean from locking the world in ice. Between these bounds lies a narrow country where life could persist, not because conditions are sweet, but because they are consistent. He contemplates giants that accept the lash more gracefully. A gas giant at a cautious distance can soak storm energy into its magnetosphere and radiate it as radio arcs strong enough to be heard across light years. The arcs are not merely storms, they are signatures of a planetary cyclotron shouting at frequencies set by field strength. If a rocky moon circles inside this machine, its own aurora will paint polar nights, and current loops will bind planet to moon in luminous ropes. Detection of such ropes would be a triumph for patience and for instruments that can listen low and long. He moves to star-forming regions where compact remnants and newborn planets share neighborhoods. A protoplanetary disk that wanders near a magnetar does not keep its innocence. Dust grains charge and levitate. Gas ionizes. The magnetorotational instability that stirs the disk becomes ferocious. Viscosity rises and falls in patches, birthing rings and gaps that owe nothing to planets, and everything to an external lightning that never lands. The disk may disperse earlier. It may also assemble curiosities, tightly packed worlds or oblique planes, dictated by magnetic torques rather than by calm accretion. The population of planets emerging from such cradles would differ, and their stories would carry the accent of their dangerous nursery. He examines biology as a chemist with a poet's patience. Ionizing radiation damages, but it also mutates. If exposure is chronic and moderate rather than catastrophic, it supplies novelty on schedules that evolution can sometimes harness. The boundary between too much and just enough is tight. A stormy, compact neighbor tightens it further. Surfaces would be sculpted toward resilience. Pigments would serve as armor and sensor. DNA repair would be culture rather than crisis. Ecosystems would migrate diurnally as flares come and go, tides of light driving tides of shelter. He checks the ledger of existential risk for his own sky. The nearest compact storms are far enough that their tantrums brush Earth with decoration, not harm. Yet a giant flare in the wrong neighborhood could play games with the ionosphere and technology. Global communications would groan. Polar flights would replot. Power grids would practice humility. These are small prices compared to geology. Past mass extinctions on one blue world have drawn suspicion toward gamma outbursts at galactic distances. Compact engines like these contribute to that background. The threat is low on any given day, but non-zero across deep time. A species that writes long histories should note it without despair. He returns to the virtue of measurement. Worlds under the lash advertise lessons about magnetic weather and atmospheric escape that no quiet system can teach. They calibrate models that predict the fates of planets around ordinary red dwarfs, where flares are common even without hard gamma companions. They anchor the practice of reading air for trauma. Each transit spectrum across many waves becomes a confession about winds and fields. Each radio arc traces a circuit. Each soft X-ray brightening is a flare echo in chemistry. These tracings turn drama into data. He imagines a future probe skimming the safe edge of such a system. It would carry a magnetometer that would sing rather than record, a mass spectrometer that would taste ions departing a world, a polarimeter that could watch light twist as it crossed the halo of the compact star. The craft would not adventure inward carelessly. The mission profile would read like mountaineering, with careful camps, short dashes, and a strict respect for weather. What it would bring back is not only images but a grammar of survival, in places where survival is chosen every hour. He closes the sketch with a simple sentence written in patient light. Danger is not the absence of life, it is a teacher. A compact star teaches by excess. Planets that orbit nearby turn that excess into chemistry, structure, and sometimes endurance. For distant listeners, these worlds are beacons of method. For their own skies, they are theatres of pressure and release. He sets down the chalk and lets the model spin. The atmosphere of the small world thins and thickens in cycles carved by storms. The ocean falls silent under auroral noon. The night beyond the pole glows in curtains that whisper a promise. The promise is not comfort, it is continuity. He arrays the instruments as one might arrange a choir. Each voice answers to a different piece of the spectrum. Some are tuned to hard light that teeths at electronics. Others bend their ears to radio whispers that last a breath and are gone. Together they make a single machine whose purpose is to catch lightning that never touches air. He begins with the sentinels that never sleep. Wide-field gamma monitors watch the whole sky, their crystals clicking at each collision of a high-energy photon with a lattice of atoms chilled for discipline. The time tags on those clicks are precise to microseconds. When a spike arrives, the electronics split the torrent into energy channels and count. Dead time looms during the fiercest seconds, and software learns to correct for blindness imposed by brilliance. A trigger is formed when count rates outrun their background, in a way statistics cannot deny. An alert propagates across a network, a short telegram that carries time, rough position, and the promise that the sky has shouted. He moves to the nimble X-ray telescopes that pivot at a command. Narrow fields find the source that the sentinels only hinted at. Detectors built of silicon or cadmium telluride paint spectra at key EV energies where surfaces glow and magnetospheres harden. Pile-up threatens when the source is cruelly bright, so observers defocus, tilt, or switch to fast readout modes designed for storms. With each photon, the telescope records time and energy. Later, the light curve is binned with care, or left unbinned and searched with Bayesian blocks that find structure without prejudice. Phase-resolved spectroscopy unfolds hotspots into geography as the star turns. He lays a polarimeter alongside them. The camera does not ask how many photons came, but how their electric vectors were arranged. In magnetized vacuums, polarization is a map. Compton scattering and photoelectric effect analyzers reconstruct angles through the dance of secondary electrons and scattered photons. The fraction of ordered light and the sweep of its preferred direction tell how fields lean and where density changes, force modes to exchange identities. During a flare, the angle swings like a compass near iron. During quiet states, it settles into a shape that draws magnetic topology as surely as a charcoal sketch. He turns a dial to radio. Arrays with hundreds of antennas fold their beams coherently across the sky, looking for millisecond seams in the fabric of noise. De-dispersion removes the smearing that cold electrons impose, aligning frequencies so a true impulse can show its edge. If baseband data are saved, the burst can be refocused after the fact, substructures resolved, and polarization reconstructed with a surgeon's patience. Radio frequency interference is the false thunder of Earth. Machine learning learns to ignore it, rejecting signatures that lack celestial dispersion or carry the fingerprints of human industry. When the real thing appears, a dynamic spectrum drips with structure. Bands brighten like stacked harmonics. or drift in frequency as a shock sweeps through a gradient of plasma. He adds the geometry of distance. Localization begins with timing. If 3 or more high-energy watchers hear the spike at different moments, the delay annuli cross to a small patch. X-ray telescopes then dive to that patch and find a point source whose spectrum fits a hot surface with a hard tail. Radio interferometers refine the address with baseline lengths measured in continents. Very long baselines turn the sky into a ruler with hair-width marks. A repeating burst pinned to within milliarc seconds can be married to a faint, persistent radio haze that outlines a nebula wounded by wind. He listens for the Earth's reply. Ionospheric monitors watch very low-frequency radio paths lengthen and shorten as charged layers rise and fall under sudden ionization. A spike flips their records like a page. Magnetometers in polar latitudes hear ground currents surge as the upper atmosphere conducts in new patterns. Even instruments strapped to satellites designed for chemistry or weather note when particle fluxes rise. The planet becomes a passive detector whose skin is the screen. He attends to the economy of time. The most violent light arrives and fades before a sentence can be spoken. Pipelines run without a human in the loop. Event lists with nanosecond stamps stream into ring buffers that hold only seconds. When a trigger rings, the last heartbeats are preserved. After the flare, specialists reach into those caches to pull out the earliest photons, the ones that contain the least processed truth. Without that capture, the spike is only a rumor told by the tail. He inventories the mathematics used to turn raw arrivals into story. Power spectra search for quasi-periodic oscillations by comparing variance to expectation across frequencies. Pulse profiles are decomposed into harmonics, whose relative strengths betray hotspots that are not round and magnetic axes that are not kind. Spectra are fitted with models that include Comptonized tails, cyclotron features if they exist, and cutoffs where photon splitting or pair creation steals energy away. Joint fits across time show how the fireball cooled, how the optical depth fell, how the geometry simplified into a calmer order. Each fit yields parameters that are less poetry than confession. He names the practice of coordination. Alerts ripple through a web that binds observatories on the ground to those in orbit. A burst at high energies prompts an automatic request for radio follow-up. A radio bark with steep dispersion cues X-ray eyes to stare and wait for a partner. Even neutrino and gravitational wave antennas listen, not because they are sure of hearing, but because they have learned humility. Most of the time they record silence, that is itself a limit on models. Sometimes a marginal excess twitches, and the community holds its breath before admitting that this time the ghost remained a ghost. He strolls through the workshops where hardware is made uncompromising. Detectors are cooled until their noise is a whisper. Mirrors are shaped to concentrate photons that refuse to be focused by normal glass. Readouts are designed so that the brightest second of a decade does not blind the machine built for the other 300 million seconds. Calibration consumes days, because an error bar is truth's border. Polarimeters are rotated on known sources to ensure that their azimuthal responses are honest. Radio arrays have their cables measured, so lengths are known to a centimeter across fields that stretch to the horizon. Without such pedantry, flares would be spectacle without measurement. He pauses at the threshold of the future. New polarimeters will probe harder bands where vacuum effects grow dramatic. Fast X-ray imagers will time photons to microseconds while drawing pictures with arc-second precision. Large radio dishes will record entire basebands for minutes so that any burst can be refocused at leisure. Timing arrays will measure pulse arrival wanderings with the ambition to see low-frequency gravitational murmurs from other beasts, and in passing will keep the pulse archives that reveal every stumble and recovery of the compact star's clock. Prototypes for high-energy interferometry dream of synthesizing apertures at MeV energies, where pulse tails glow and cyclotron shadows might be caught. He remembers the quiet instruments that are only sometimes loud. Optical telescopes rarely see a flash, yet they can catch the slow echo in nearby gas. A narrow line brightens as a cloud is shocked by a particle rain. The line cools with a memory of the flare's spectrum. Infrared cameras see embers where dust was heated and then exhaled its warmth back into the night. These are not headline signals, but they are footnotes that later become paragraphs. He visits the room where data are curated. Petabytes of photons wait on drives that hum in climate control. Metadata record weather, instrument mode, time standards, and every nuance of configuration. Without that scaffolding, a scientist years later could not reconstruct context. Machine learning mines the archive for shapes our eyes miss. Outlier searches find bursts that were too faint to trigger but many in number. Stacking them reveals a population of micro-events that, integrated, power a significant fraction of the persistent glow. Discovery persists in old files because storms leave eddies that can be recognized only in hindsight. He closes with an image of a control center at night. Screens show jagged light curves, rotating polar plots, radio waterfalls, and world maps with antennas lit where night has already fallen. Someone sips cold coffee and watches the seconds tick. An alert arrives. The room sharpens. Commands move. Dishes turn. Apertures wheel. Times are noted down to the microsecond. The flare crests and then declines into the choir of background. Later, when the sun comes up, the event will be ordinary in the history it joins. Yet, in the instant of capture, the universe presented a page and the instruments wrote on it. The handwriting is precise. The language is technical. The meaning is human. To hear lightning in space is to practice attention at a scale worthy of the danger that made it. He unfolds a calendar of instruments that do not yet exist in the sky, but already live in blueprints and laboratories. Each carries a promise to test ideas that have been patient for decades. The first page shows a camera that does not measure brightness alone, it measures how light is oriented. Across the key EV to MEV band, polarization becomes a ruler for the shape of magnetic fields and the density of pairs. A polarimeter with large collecting area and fast timing could watch angles swing during a flare and watch them settle as a trapped fireball cools. Mode conversion across a resonance would leave a clean kink in polarization fraction versus energy. A single clean kink would weigh the density profile above the surface and the strength of the field where photons last argued with the vacuum. He traces an orbit for a mission that loves the MEV sky, a band that holds the most decisive physics of splitting photons and birth of pairs. Past detectors were small, efficient only when storms were generous. A modern Compton telescope with advanced trackers could resolve spectral shapes in the spike and the tail, with enough fidelity to separate curvature radiation from Comptonized surface light. If photon splitting operates strongly, cutoffs and slopes will carry its signature. If it does not, a different engine must be at work. The same machine can search for cyclotron features from protons in the strongest fields, faint dimples in the spectrum that would anchor the surface field to a number rather than a metaphor. He sketches a radio array with a memory that is nearly perfect. Instead of saving only triggers, it saves baseband streams for vast swaths of sky, compressing them in ways that preserve phase. Any burst that later proves interesting can be reassembled at leisure. Microstructure down to tens of nanoseconds becomes accessible. Coherence lengths and emission altitudes can be inferred from how subpulses drift. A distributed network of such arrays on several continents and on one cold desert plateau lets triangulation reduce positions to tiny patches fast enough to command X-ray and gamma eyes during the same minute. Coincidence becomes routine rather than grace. He lifts his eyes to gravitational detectors that listen for the tiniest shiver. Continuous waves from a star with a slight asymmetry are quiet, yet a generation of interferometers with longer arms and colder mirrors will lower noise in the bands where a city-sized mountain of a millimeter can sing. If a tone is found at twice the rotation frequency of a compact star, amplitude and phase will deliver the product of ellipticity and distance. Timed against spin down, the gravitational luminosity can be separated from the electromagnetic break. The remaining torque belongs to magnetospheric drag. A second class of shiver might arrive as a sharp ringdown when a crustal quake excites global modes. A narrowly timed coincidence between a flare and a damped oscillation would turn theory into cartography. He adds a neutrino ear cut from ice and ocean, buried photomultipliers already listen for supernovas. They could also listen for a subtler rain when a compact star rearranges its interior and lets Cooper pairs form or break. Such neutrinos are few, yet a nearby event could lift them above background. Even a non-detection that brackets the allowed fluence would narrow the menu of microphysics. A fleet of smaller detectors spread across hemispheres and depths would keep watch when one day's sea is too loud and another's sky too bright. He draws a map of a lunar far-side array that listens below the ionospheric floor. At tens of megahertz, the Earth is noisy and opaque. The Moon's backface is quiet. There, long dipoles could hear coherent radio shocks launched in giant flares, signatures that the ionosphere on Earth would bend and spoil. Combined with high-frequency arrays at home, the full radio portrait of a storm could be assembled from kilohertz whispers to gigahertz barks. Plasma physics would no longer be inferred from fragments but read with continuity. He lays out a constellation of nanosatellites that behave like sparks around the planet. Each carries a small detector and a clock that never doubts its own seconds. When a storm arrives, arrival times across the swarm read like an interferometer of light speed. Parallax on microsecond scales fixes the location better than any two telescopes could. Timing footprints also betray substructure in the spike that single detectors miss when dead time forces blindness. The constellation is cheap compared to a flagship mission, yet it adds a dimension that single giants cannot offer. He turns to terrestrial laboratories where matter is coaxed into temporary regimes that at least rhyme with those in the dangerous sky. High-intensity lasers drive plasmas to fields and densities where quantum electrodynamics shows its more elaborate steps. Vacuum birefringence over centimeter paths can be tested by sending polarized beams through magnetized cavities and watching angles tip by nanoradians. Fusion experiments confine hot matter with magnetic bottles that threaten to break by reconnection, letting cameras record the reconnection's tempo. The timescales and strengths are toys compared to a compact star, yet the scaling laws are the same language. In this translation, confidence grows. He writes a proposal for timing that never loses count. A global effort watches a handful of compact stars daily, folding pulses with templates that learn slowly so real drifts appear as themselves. Whenever a rotation steps or a derivative bends, other facilities receive a call to stare. Pulse shape changes, hardness ratios, and polarization are recorded at a cadence high enough to like-for-like compare against the timing event. With 5 years of such discipline, the ledger would classify glitches into interior-driven, magnetosphere-driven, and mixed. The ratio would choose among microphysical models more decisively than any single outburst can. He glances at a plan to capture thermal echoes. A fleet of soft X-ray and ultraviolet spectrometers with moderate imaging capability survey target lists after each timing event and after each storm. When heat emerges days or weeks later at the surface, its spectrum and motion disclose the depth and geography of the triggering accident. Repeated echoes build a tomographic map of conductivity, impurity content, and field direction under the skin. The map would be crude in its first drafts, then sharpen until predictions of hotspot evolution become campfire talk rather than novelty. He imagines a mission that stares at a single compact star for a year with no other duties. It spins and the instrument spins with it in software, keeping hotspots in a fixed instrument frame. Every photon is counted. Pulse profiles as functions of energy are built with millions of counts per bin. Subtle changes in harmonic content reveal precession or tiny shifts in the angle between the magnetic and rotation axes. Slow migration in phase announces plastic flow at foot points of loops. From this tireless stare, a choreography emerges that folded campaigns miss because they look away between nights. He invents a population survey that does not select for brightness. A sensitive all-sky X-ray map refreshed monthly reveals faint, persistent embers that could be compact stars with decayed fields and low budgets. Their inclusion breaks the bias that only loud lives teach. Field decay laws extracted from the full family gain credibility. Lifetimes inferred from birth rates cease to be sketches and become measurements. The survey's slow roll also finds subgiant outbursts that never trigger alarms yet show textbook reconnection physics in miniature. He marks the value of close examples. A welcoming remnant within a few thousand light-years would be a school. The backyard target permits parallaxes, proper motions, and searches for nebular halos of hard electrons that glow at radio and X-ray energies. A small probe could cross its environment with an imager that reads polarization and a magnetometer that maps shocks. Flybys at cautious distances would taste particle populations and watch field lines in situ. The mission profile would be austere and safe, yet it would turn inference into direct encounter. He refuses to forget the budgets. Ambition must speak to cost. Many crucial tests live not in single grand observatories but in networks, constellations, and programs that commit to cadence. Shared time protocols, common data formats, and open archives make a merit of modest instruments by letting them act in chorus. Software that aligns seconds across sites and fits models the same way. Everywhere turns a community into a single telescope larger than any mirror one nation can loft. He closes the calendar with a promise written in practical ink. If polarization swings with energy during storms, if MEV spectra show splitting, if continuous waves hum at levels matching millimeter mountains, if neutrino ears remain quiet during certain favored flares, if baseband radio reveals subpulse drifts that agree with shock curvature, then the central mystery yields a tier of its secrets. If those signatures do not show, the field will change its questions rather than its rigor. Either way, tomorrow's tests are not decorations. They are the last steps before understanding is permitted to stand without adjectives. He stacks the pages and sets them aside. Instruments become sky. Hypotheses become numbers. The most dangerous stars prepare their next lesson, and the world that listens prepares to measure rather than merely admire. He stands at the edge of a quiet that is not absence. The sky seems ordinary, its silver river unbroken, its dark, untroubled, instruments idle, data rates drop to the soft murmur of background. The furious light has gone. In its wake lie numbers, images, timing files, and the stubborn warmth of a star that has folded its fire back into itself. The world becomes aware again of crickets and traffic and the rhythm of an ordinary clock. Yet, the memory of high energy remains like heat in brick after sunset. He studies the field of aftermath as if it were a landscape at dawn. A nebular ring exhales the last of its shocked brightness. Electrons, accelerated when the magnetosphere tore, give up their momentum in swaths of radio glow that slowly dim. A cloud far downstream shows a bruise of ionization, a pale sign that a wavefront once passed. The magnetosphere holds a simpler shape, closer to symmetry, less intricate in its storm lines. The crust cools by imperceptible degrees. The rotation resumes its drift in period, imperturbable to the human pulse. The great event recedes and leaves a signature written in patient curves. He weighs what the storm added to the galaxy and sees a subtle generosity. A wedge of energy left the star and joined the interstellar fund. Some of it became cosmic rays with a new entry point into a spiral arm. Some of it warmed dust in arcs that will later participate in another round of planet-making. Metals dislodged in the long past still ride the shock front, a reminder that even long-dead stars manage to contribute again when their remnants speak. The galaxy is not a set of isolated fires. It is a living economy. Violent engines move the currency more vigorously. Peaceful ones spend more slowly. Together they pay for structure. He reflects on the way danger clarifies. In ordinary light, comfort supplies its own paralysis. A dangerous star denies that indulgence. It acts as a teacher, with no inclination toward small talk. Under its instruction, a community learned modes and frequencies, built new instruments, fortified methods, and wrote down uncertainty as if uncertainty were a friend. The object refused to accommodate easy narratives. In response, patience sharpened. In sharpening, a habit of attention emerged that will persist long after this source falls quieter than noise. Attention is a muscle that does not forget its training. He recognizes an elegance that hides in rough manners. The star is compact, yet it represents the union of three domains that are often kept in separate rooms. Gravity rounds matter into a city-sized sphere and bends light enough that a distant viewer sees more than half a surface at once. Quantum electrodynamics turns vacuum into a medium, seasoning it with birefringence and setting polarizations at war and peace along their path. Nuclear physics supplies the stiffness and the strangeness of the interior, a catalogue of phases that carry rotation, pin vortices, trap field, and release it on schedules that ignore metaphors. The whole is not orderly in a domestic sense. It is orderly in the way an ocean is orderly. What appears as caprice is a spectrum of processes, each obliged to rules that never forget their context. He considers meaning without bargaining for comfort. The star is not cruel. Cruelty requires intention. It is simply intense. The danger is a concentration rather than a moral. Yet even in a universe indifferent to human drama, significance ripens when minds attend. A flare that brightens a whole galaxy for a breath marks a moment of extreme reconfiguration in the world's library. That page is valuable. It shows what matter can do when forced to accept unheard pressures and tangled fields. It suggests that creation comes in two tempos. There are low songs of accretion and slow fusion. There are high songs of collapse and lightning. Both produce structure. Both feed the tapestry. Together they prevent a flat universe from growing dull. He follows time beyond the window of a single life. The field decays by inches, its heat budget still banked in the crust. The rotation slows toward a period that no longer scratches, bulk charges from the surface. The storms become fewer, their edges less knife bright. Eventually the star rests in a cooler state, its once tyrannical magnetosphere, a calmer lodge for a weaker wind. Another kind of star takes up the role of visible terror. The baton passes. The old actor remains on stage as a dim figure with a hard surface and a memory. That memory is geology, pattern, and a set of lines in archives that will outlast fashion. In the slow arithmetic of the galaxy, no learning expires. It is stored in quiet shelves of method, and in the next generation of observers trained by these knights. He thinks of the human near-field. Lights on the ground answer to faint signals from distant storms. The ionosphere ripples. Circuits count unexpected particles. Power lines hum in a slightly altered register. Pilots file different routes. None of this reaches into myth, yet each detail ties daily life to a drama far away. The connection is not mystical. It is electrical and precise. That precision is its own wonder. To live in a world where decisions can be altered by a star, tens of thousands of light years distant, is to live with a sense of horizon that dignifies even the smallest choices. Work done carefully here will be valuable there. Care is a line that travels better than light. He inventories the virtues that such objects demand. Humility, because the object will mislead anyone who insists on speed. Rigor, because the sky is full of provocations that mimic significance, and the only defense is attention to noise. Imagination, because the interior cannot be touched and must be understood by inference that is guided yet brave. Patience, because the alarms ring at their own convenience and instruments must be tended in ordinary seasons to be ready for the hour that matters. None of these virtues are solely scientific. They are useful in every craft worth dignity. He turns the camera inward, not to confess but to observe what a mind is when it has just learned. There is an openness that arrives when a theory is supported more securely than before. There is a corresponding silence when a cherished idea does not survive contact with data. Both are useful weather. A dangerous star is generous with both. Its generosity trains resilience. Resilience becomes culture. Culture becomes the instrument by which the next generation sees further than the one that built the first mirrors and dishes. He lets the image of the star shrink until it is a bright point in a wide field. Around it lie clusters and lanes and the pale smoke of unresolved suns. Somewhere in that field are worlds that will never fear this small remnant, and others that once did. Somewhere in that field are minds that might learn similar lessons with their own instruments, born of their own physics. He does not need to imagine their faces. It is enough to imagine their attention, steady and courteous before a sky that permits no compromise with sloppiness. He takes inventory one last time. A city-sized object with pressure like a verdict. A field that turns space into a lens. A crust that can hold a mountain and then break with the energy of starlight. A clock that falters and in doing so translates superfluidity into timing graphs, a magnetosphere that refuses to remain simple and therefore writes storms of reconnection, worlds nearby that suffer and adapt, instruments built to nail the exact microsecond to a page. The list belongs to a library of reality. The poetry is not added by the mind, it is already there. He chooses a sentence without ornament. The roar is a form of attention. When it ends, the attention remains. He files the last record into an archive that is not a grave but a launch pad. Somewhere, perhaps in the same patch of sky, a new spike will rise in a future night. Somewhere, perhaps on another world, some creature will look up and read an auroral curtain that owes its glow to a distant engine. The dangerous star returns to quiet. The galaxy remains loud. He closes his eyes for a moment in a room filled with soft instrument noise and the steady hum of cooling fans. In that simple sound, he hears endurance. Endurance is a translation of the universe into the only language humankind can truly speak. Careful work for long spans of time. He steps outside and the air tastes like rain though the sky is clear. A single planet hangs above the dark edge of rooftops, and the river carries city light in wrinkled gold. Far across the arm of the galaxy, a compact ember turns without audience. Its fields rise and fall like a chest at rest, the storm stored in geometry the way a hymn is stored in breath. He does not ask for spectacle, he asks for a reason to keep the night shift. That reason walks down a quiet street with him in the company of lampposts and leaves. The reason is that for a few hours of a life, a mind was aligned to an object that requires honesty. The alignment leaves a mark. It is not revelation. It is a calmer spine, a slower voice, a promise to discriminate between noise and signal in the ways that matter at home. Clouds move in from the west. He feels the temperature change and imagines a magnetosphere adapting to new stress with the same calm ferocity. If it breaks tonight, the ionosphere will answer, and radio waves will paint faint lines across stations whose DJs never knew they were inside an experiment. If it sleeps, the quiet will remind him that silence is as much an instrument as any mirror. He unlocks the door and turns off the lights in the control room. Screens go black one after another. In the drawn-down brightness, he can see his reflection, and behind it, the stilled glass of a telescope that will not move again until dawn. What was learned today will be small in the library of the universe, but it will be clean and it will be kept. He writes a single sentence on a pad beside the console. Keep listening. Then he slides the chair in, steps into the hallway, and lets the door close with a sound that feels like punctuation rather than end. The sky waits. The pulse waits. The next measurement is already on its way. End of script. Sweet dreams.